The most important part of dance is music. So now let us listen to the music and identify the beats.
1, 2, 3.
But that was too soft.
Around now, jump around now, jump around now, get down, jump around now, jump around now, jump around now, get down, jump around, jump around, jump around now, jump up, and get down, jump around now, jump up, and get down, jump around now, jump up.
Hey chat, how's it going? Welcome to today's stream. Apologies for the ever so slight delay today. YouTube was not cooperating, give us a little bit of a fright, but we got everything working. So I won't delay too much so we can get right into things. But before we get started, and before we say hello to Dave, I'm just going to very quickly say some hellos in chat. Kerr, thank you very much for 8 months VideoDojo Plus channel membership. I really appreciate your ongoing support, and it is great to have you with us. Who else is here? I did see Disco stopped by. I hope you enjoy the VOD later on, Disco. OMG Kid Time, Curbs Workshop, FUZE Arena, who's this? Nintendo Plush, Curbs Workshop, again, Steve's Gaming, Sunshine Burrito, Starry Nomad, hello, Dalmont, James Morris, Movies XP, great to see you all. We've got a wonderful FUZE4 stream in store today, and of course, I am joined on my journey by the incredible Dave from FUZE Arena. Dave, how you doing?
The incredible. That is a prefix and a half.
A well-earned title.
I might demand that from more people in my life, actually.
Put it on your business card.
Well, my business card originally had Paragon of Truth on it, which I demanded.
That's also
because
very
back
nice.
In the early days of FUZE, when it was for a time, it was just sort of me, John, and Luke for this sort of development period of FUZE for Nintendo Switch. We all had our own Paragon titles, and John was the Paragon of Adjudication. I was the Paragon of Truth, and Luke was the Paragon of Wisdom, and we had it on our business card.
That's so good. That's
in incredibly small print.
Yeah. How many people called you up on it? Like, how many were like, what's this here? Sorry, what's this little byline on the business card?
Not a single person did. It might have been too small. The text was very small. I think it was the only way I could. The only way I could convince John to do it was by making it basically imperceptible.
Put it in like white font on white paper, and you were like, it's technically there.
Yeah. Oh dear. No, I wouldn't have been happy with that.
No. You got to be able to see it to believe it.
Yes, yeah. It needs to be at least slightly viewable.
So when it comes to time to print it again, it's going to be Dave, the Incredible with caps. Paragon of, what was it?
Paragon of Truth.
Of Truth. Okay.
Yeah, indeed.
You like the aliens from Halo.
Oh dear. Well, my friends at home, they have a really long list of middle names that they give me sometimes.
Ooh.
Which I'm not going to list any of because they are. It's essentially a document that is added to every time. And I've got 2 more editions for that now. The Incredible.
There we go.
I'll force that one. Anyway, it's really good to be here, Dom.
It is so nice to have you.
Thanks for having me again.
You're very, very welcome. It is always a delight to have you on the channel and to have you guide us through some more FUZE, which is exactly what we're going to be doing today. So if you just give me a moment, I'm going to bring the incredible Jet Set Radio. I've used it again. Look, the incredible Jet Set Radio soundtrack for the Incredible Dave. There we go.
Oh, I'll tell you, yeah. This is satisfying some, I don't know, my like 13-year-old self in some really deep way. It's like therapy, this is, to be honest. Because that game was very, very deeply important to me as a child. I mean, it's kind of single-handedly the reason why the Dreamcast will always be a favorite console of mine, if not my sort of favorite. Because I don't know, I had the Dreamcast and I had Jet Set Radio, and it was just that and Skies of Arcadia. If you played that.
Ooh, yeah. So that was one that I always like. I remember seeing the box for that in the local game shop, but it was not one that I ever played myself. I feel like the Dreamcast, excuse me, had so many like incredible box arts that just made you were like, what is this game? I really want to play this game. And even if it was one of those that just, you never got around to playing it, you were like so intrigued because the artwork was always so good. I feel like I can picture it in my mind.
Yeah, you probably can. It was just an incredibly good JRPG.
Yeah.
That sadly never got the Switch release that it desperately needs. Desperately needs. I would. Oh God, I'd love to see that.
The perfect.
It had a GameCube release, but it's now like silly money to get a copy of. So
right.
Yeah, it's one of those. But yeah, and also a big hello to the chat. Obviously, hello to Dom's lovely community and to some of the FUZE regulars. I notice some names in here.
Yeah, it's it's
really good to be here, everyone.
So lovely to see names that I recognize from your wonderful streams over at FUZE Arena as well. It's really nice seeing everyone come together with some FUZE action. Now, I guess I'll do a quick summary in case anybody is joining us for the first time. We've had a couple of streams together now where we've been going over some fundamentals, which I think it's fair to say are fundamentals for coding generally and game design generally, but we're with also some really specific features of the incredible FUZE⁴ for Switch, and we've started to move towards building a little game together as well. And that's what we did on our last stream. It's been a little bit of a gap between that one and this one, so I think we'll generally do a bit of a refresher as we get into this of what we went over before. But yeah, for those joining us, I do recommend going back through the previous streams as well. If you're new to code, if you're new to FUZE especially, there's also all of the wonderful resources on FUZE Arena's channel as well. Now, Dave, should we begin with your screen or mine? Because we do have the options here.
I do. Well, let's start with your screen. If you could open the project back up. Let's just remind ourselves of where we are at. Oh, if you go to... oh, you're already on the project. So if you go to... in the program section is where you sort of select your different projects.
Yes.
The project side is your information of the current project. And in programs is where you can go into your various different projects. So if you go into code, because it's already loaded, I think, then yeah, we've got our progress thus far. So I suppose we should just do a little recap, just sort of scrolling through this. Oh yeah, well remembered, controls wise. Although I guess it does say it on the screen as well. So
I did remember that one, but it was handy to have it down at the bottom as well. Because I got my USB keyboard plugged in for those at home. Obviously, there's a lot of typing to do here, and FUZE⁴ does support the USB keyboard as well, which is super, super handy. Yeah, so this is where we got up to before.
Yeah, so that's good. It's a nice short program, so we can have a quick look, actually. If you go back to the top, we can just sort of talk over each bit. So just because when you load up some code, it's very easy for people who aren't familiar to get hit with that terror feeling. And I totally understand. It is very similar. I mean, we always liken it to looking at a page of Japanese text or something if you don't speak or read Japanese at all. Obviously, for Japanese people, that's pretty trivial, but anything that's got lots of stuff on the screen and some of it is not really that immediately understandable, if it's not something you've got some familiarity with, it starts to just all break down into random symbols that all scare you. So it's good to sort of get that laser focus on just little sections and look at each brick in the wall rather than the entire wall, to use a good analogy there. I'll just answer a quick question in the chat, actually, because it's very relevant to this point. So, Mushroomer. So is FUZE code a variation of Lua or Python? It seems similar. And then Apple. That's a good name. Apple was going to say the same thing. So FUZE code is our own language. It's a language that we developed to be very accessible for beginners. And it's somewhere in between a bunch of other languages. So it's got a lot of influence from Python. It's got a lot of influence from BASIC. There's also some C in there as well. Lua, there is also some natural similarity too, but that's not super by design, actually, because Lua wasn't one of our main influences. But it turned out that Lua actually has a lot of similarities to the way we write things as well. I mean, at the end of the day, there's only so different these things can get in terms of their syntax, but they all have their own idiosyncrasies, and FUZE has its own as well. But I would say it's probably most similar to Python syntactically, but then again, that breaks down in a few other places. Okay. So our first section.
Oh, sorry.
Yeah, sorry.
Can I just dive in with
please.
a question? This is,
Always.
not necessarily crucial here, but I think it ties into that, and it's something that I'm interested in. Are those similarities because they're all kind of stemming from a similar root language, or is it because there's a, once somebody is familiar with one language, they want there to be, there's almost conventions that are expected to carry across? Is that something that you can kind of separate how much of it is because there's like a shared origin point, or?
Well, there's always a shared origin point because the first is sort of machine code, right? So maybe drawing something would sort of illustrate my point, or maybe if you could switch over to my screen a second, and I'll just use, because I think with words a lot. So,
Mhm.
dojo.
So just for context, chat, this is now Dave's switch that you're seeing. So Dave's typing this up currently.
So I'm not going to speak too authoritatively on this, okay? Because my predominant area of expertise, I would say, is in communication and teaching, and not in the deep workings of various computer languages. So disclaimer, might say something here that is subject to some pedantry, maybe you could say.
This is a kind
But,
of a top level view of maybe some of the
Sure.
Yeah.
There's a general idea here, which is there's a concept called level in programming languages, and it doesn't mean difficulty. So you have high and low level. So if you imagine that at the very, very bottom of a computer, at the very, very bottom level, the bottom layer is zeros and ones, yeah, or the actual physical transistors,
yeah,
that occupy the various different logic chips, all distributed throughout the computer in various places, mainly centered around the GPU, CPU, etc., etc. Okay, so you've got the metal, sometimes it's just referred to as.
That's a term I have heard before, right? I guess I never thought about. It's a very literal thing, right? It's kind of saying the base, the most to the metal that you can be.
Yeah, when you hear someone say, understanding down to the metal, they mean every single layer of interaction, every single layer of processing down to the individual transistors. And at this level here, people that work down at this level, people who design chip schematics, people who do this sort of thing, they have to bear in mind some things that we just never will have to bear in mind as sort of beginner programmers. Things like the physics of electricity. Yeah.
Wow.
Because the sizes of these switches are so unbelievably, ridiculously small that you start to have to, the actual passage of electricity through fields of electrons damages transistors. The time it takes for electric currents to reach areas of the computer, different areas of the boards, this is a consideration that has to be brought into thinking. And there's the desynchronization that can occur throughout those different processes. It is a different world down here.
Yeah.
Okay, then you've got Mushroom at FUZE 4 is £12 on the eShop. I think it's $12.99.
Yes, it is.
So yeah, just to answer that question quickly. So above that, you then get into what's called assembly language or machine code. Okay, two different terms for the same thing essentially, which is the actual instructions given to the registers that hold these zeros and ones. Right, you're actually giving instructions directly to banks of transistors. You're saying, so assembly language is very, very difficult to understand, very, very difficult to learn. But like all these amazing things, when you do learn it, it's actually almost simpler than everything else because it is the most direct instruction that you can get to the metal. Obviously, nobody ever programs in binary, in zeros and ones, because it would be completely ridiculous to do so. To make any sort of sophisticated program would just take amounts of time so vast that it is just immediately, just past the point of consideration. It's not viable. So assembly language actually gives instructions to individual registers that hold data. So making a variable in assembly language is something like, move this value into this register, right? You're actually designating a register, an area of memory, to say, I want this to hold this. And then when we put it somewhere, when we use it somewhere, let's say we use a variable in a function, we need to now physically move that value into another place with assembly language.
So from what you've said here, is it fair to say that essentially you're kind of talking to the computer without translation? But
yes,
that comes with the problem that it's not very efficient to talk directly without translation to the computer.
It's the most efficient possible way in terms of what the computer wants.
Yes, right, of course.
But obviously, for us, it's one of the least efficient.
Yeah.
Now, however, if you do write something in assembly language, you have one benefit, which is that it is incredibly fast. It's as fast as it can possibly be because there is no translation required.
Right.
It's like giving something
Directly.
complete. It's like giving your muscles the electrical signals to move rather than telling a person, do this movement.
Yep.
It doesn't have to be interpreted. So that's assembly. Now, all the old arcade games that are, designed on boards that occupy arcade cabinets, they are all written in assembly.
Wow.
It's incredible that it was this way. And a really famous game that is a famous example of assembly is Roller Coaster Tycoon. Because the original Roller Coaster Tycoon was written on essentially potato computers, and it works unbelievably well, and it can do an unbelievable amount of stuff. You've got hundreds of people in a park, all with their own things, their own needs, their own tasks, their own stuff going on. You've got physics in there. Because the roller coasters have to abide by rules of physics. It's doing all of these things, processing it, it's doing the graphics, it's doing everything. The only reason that's possible is because Roller Coaster Tycoon is written entirely in machine code, in assembly. And assembly is specific to the chip that you write it on, yeah? Because you've got different chip architectures, when you get, and this is what's meant by like an x86 processor, or different systems, different manufacturers, they all use different, they don't all use different chips. They all use sort of a selection of these very, very popular ones. And now, obviously it's been fairly monopolized, where there are only a handful, a small amount of sort of chips that are used in mass production. But yes, they are chip-specific instructions for the most, not for all of them. There's a lot of things that are shared, but you get the picture of what I'm painting here. Anyway, above this, we have higher level languages. So the closest to assembly is C, pure C.
Yeah.
C was written to do exactly this. It was written as a very low-level language that is still high enough level to be understandable to, people generally. Not like you need to be a savant to. No, it's not everybody. You can learn machine code. I don't mean to mystify it and make it. Never do that. It is something that people should look at because it's literally how a computer works.
Yeah.
So C is probably the most popular language, I will say. In terms of, it is your coder's. It's a coder's language. It is a coder's favorite language, right? So Node on Guy, absolutely correct. At the very, very top level, we have something like Scratch and GBG. Yeah? Purple Mash, any sort of block-based language. Because there has to be so much translation for this then to go down here to then become machine code. And sometimes they will actually be directly translated into C before they're then translated into machine code, before they're then translated into MEL. So Fuse is also very, very high up here. I don't know if I would put it that high up, but I don't know. Maybe it would be correct to do so. This is where I'm going to, I wish I knew more, really. But things like Fuse, Python, etc., right? These are high-level languages that require lots of translation. Before they reach the bare metal, and maybe like just above C, you've got the likes of C++, C#, etc. Yeah. Oops. C#. My keyboard's on American layout. Okay. So this is the general picture of like where coding languages sort of live in the overall, not hierarchy, because it's not a hierarchy. There's no superiority here. All that matters is, I mean, I guess you could say it's superior in terms of its speed or efficiency, but that's where that stops.
Well, to me, it seems like almost like a sliding scale of how immediately can somebody grasp this? How much is it kind of reworked in a way that is, easy for us to understand rather than for the computer, which, you know, as you get down to the assembly language, the machine code, the metal, there is less and less translation of that for the computer to understand it, and thus it's more efficient. So yeah, I suppose it's definitely not a hierarchy, it's just that sliding scale between those two ends, really.
Yeah, I would say so. And so any language that is made now is going to sort of have all these vestigial parts to it from everything that's come before.
Yeah.
So, because also, like, I guess you could just make a language as just an exercise of curiosity. But if you were going to make a language that's intended to be used commercially, well, you're going to have to do something that is, you know, desirable, that isn't covered by all these other things. And there are a few different choices that you can make. And one of the choices that I want to talk about here is a really key difference, which is key in understanding where Fuse lives. So you've got something called interpreted languages or compiled languages.
Okay.
So a compiled language, like C, builds an exe file. Yeah.
Yep.
So when you write a C program, you actually build that, and it goes through and a bunch of different types of, let's say, systems, namely parsers, lexers, interpreters, compilers. These systems go through and turn your code into machine code, and then they turn that list of machine code instructions into an exe file that also contains everything else, all the images that you might need to load or whatever else you're doing, compressed. And then that is what happens when you click an exe. You're actually just telling the computer to run a series of machine code commands that's been boxed up in a little package called an executable. Now, that is not what Fuse is. Fuse is an interpreted language, which means it has a bit of a ceiling on its speed. Because if you make an exe, it's gonna run as fast as it possibly can because it's machine code. But in Fuse, in order to have it be hyper immediate feedback, so that if you make a mistake and you need to go back and change something, you don't have to wait for it to build again, which is something that was very important to us because we wanted that immediate feedback, very, very quick, back and forth, make an error, correct it, try it, correct it, you know. What you have is an interpreted language, which actually reads and interprets the code as it goes. So it doesn't build an exe. When you run a Fuse program, it's not building anything. The reason it happens immediately when you run it is because it just starts it has to do some. Okay, I do tell a bit of a lie. It has to go through the whole file and sort of tokenize things, turn it into a list of instructions that isn't exactly Fuse code, but it's not machine code either. It turns it into some sort of tokens and then goes through all of these things, running it as it goes, which is also why in Fuse you won't encounter certain errors until it happens in the code. Whereas in a compiled language, every single line has to be exact because it needs to know everything that's going to happen in advance before it can even do anything. And if you miss a single letter out somewhere, it's not just when it gets to that it's going to be a problem. It's when it's even reading it, trying to understand it, trying to do everything else. So it's that's where the main difference is. And so Fuse is a compiled language. And so when you ask the question, all this was just to answer the question. In terms of these conventions and stuff, it depends on what you want it to do. If you're making a compiled language, then there are certain sets of conventions that you're going to have to abide by because there's just no other way of doing it.
Yeah.
If you're making an interpreted language, well, now the playing field's a lot more open in terms of your particular idiosyncrasies that you want to go down the route of. And what sort of things you want to sacrifice, what sort of things you want to compromise on. And it's all down then to the developer, I suppose. And there are a few master values that we have that dictated our choices as we went through. So for example, one thing that we really, really cared about in Fuse is that we didn't want to have to do something like this. Let's say I want to make a variable which is going to be a size, right?
Yep.
In C, I have to say this is going to be an integer. I have to, because for it to store the number 10, it also has to know how much memory do I need to store this thing, and how much memory that is dictated by what type of thing it is. So I'm saying I'm going to make an integer, and then the interpreter or the compiler is going to say, okay, that's going to need this much memory. Here's a box of this size, and it can never be more than that. And so that is something that you can do this in Fuse. Okay, we'll let you do this if that's what you want to do. That's fine, but you don't have to. And for it to not have to, Fuse has to do some things that are, in terms of like how the program is running, how fast it can possibly be. You could say that they're inefficient. They are inefficient. It's giving you way more memory than you need to store things. But the result of that is that it is ridiculously flexible, and it means that you don't have to worry about not using the right type when you make a variable. And it also really helps explaining it to brand new programmers and children.
Yes.
So that sort of compromise is where that discussion of conventions and how you want to go about these things sort of really meets the road, I suppose. If that at all answers your question. I know it's not very succinct, Dom.
No. That was, I mean, thank you very much, because that was a very unplanned aside, but it made so much sense to me in a way that previously I didn't really understand why there were differences. Is it just that people like to do things in a different way? But I'm realizing now that there is compromises that are made. Certain things will be better at certain things. And I didn't realize the significance of having to compile stuff and the quickness and the way that you can iterate on that. And obviously here in Fuse, having that responsiveness is really essential to know where you've made mistakes and to see your things working as quick as possible. Because I can imagine if you had to then compile all that and wait, and you realize you just need to change one value or something, it would really slow down the flow of things.
So exactly.
Yeah.
You're great, you are, Dom. You listen so carefully, and you just say it all back in this really succinct. It's great. It's such a pleasure telling you stuff.
Dave, I was just listening
Really
through as you were explaining that, and really, majority of what you just talked about was completely new to me. And I imagine there'll be people in chat of varying degrees of familiarity with that. But you really explained a lot of information there really, really clearly. So, no, thank you.
You're very welcome. And you must always take an aside to ask. And if I don't know, I will just say that.
Yeah.
But if I know a bit of bits and bobs, and I can maybe shed some light onto some stuff, then I'll be very, very happy to.
Yeah.
So anyway, a couple of questions on the chat there. I suppose GBG and Scratch would also do that since they run instantly, right? As in they're an interpreted language. I'm not going to say confirmed definitely, but I would imagine so, yes.
Yeah.
I would say so, probably. I don't exactly know the ins and outs of GBG's behind the scenes and Scratch's behind the scenes to say with total confidence. And then maybe reality is the top level, Toxabunny, this is. Had to make a channel. Maybe reality is the top level, no programming required at all. You just go out, buy a mouse and some cheese. I think we're being told that we want to go back to the program. Oh dear, that's a cool comment. And
nudging us back to the original topic. Yes,
indeed. And I mean, so Steve brings up a good point as well, which is that he thinks that all languages aren't really as good as BBC Basic. And I know that there's some facetiousness in that comment, but BBC Basic is a very powerful turning point in the road, and it was made very, very similarly to the ethos behind Fuse. We wanted to remove the barrier to entry, and that was what the idea behind Basic was. It was designed to be an accessible programming language, and that period, Basic was the language that most of the people that caused the biggest waves in the modern world, products like Microsoft, this sort of thing, these sorts of operating systems, they all learned Basic. Basic really changed the game, and it's a big influence in Fuse. So it's worth mentioning. Okay, so Tom, I'll hand back to you there. Okay. We can go back to your screen now.
All right, let's switch over. Okay. So with that all in mind, this is what we had last time, and we were going to go through. Yes, okay, because we were talking about how it can be daunting to see this flow. And I'll be honest, it's been a little while since our last one, and I'm looking at this and I'm thinking, oh boy, there's parts of this that I remembered the reason that they were here and how they related into everything, connected into everything. But now I couldn't tell you why they were that way. But I think we did help. Our past selves helped our present selves by kind of organizing this in a way that would make it easier when we came back to it.
Yeah, that's why you write comments. This is case in point why you write comments, and it's just Brilliant. Thank you very much, past selves.
Yes. Yeah.
So we made an image. The thing that we're not seeing here is that we made an image in the image editor, and we also made a map in our map editor.
Yeah.
And that was sort of the main focus of the last stream, which was using these tools in FUZE to make creating
Works of
a game
art.
project a bit more.
Works
Yes,
of art.
creating
Beautiful
perfect,
works of art.
objectively perfect works of art, which you blew us all out of the water with. And yeah, so we are loading those images and that map that we made into our project, so that we can access them in this program. That's the first couple of lines.
Mm-hmm.
The global variables section, we've got a controls variable, which this isn't necessarily, another disclaimer is that there's a million ways to skin the proverbial cat, of course, to use a violent analogy. And this is just one way, okay? So it's just a few of these things that I've found that are quite helpful for me. And I think that they make a couple of things easier that you don't have to really think about then later. But there are, of course, more ways to do it. But I like to have a global controls variable, because that means we can now, in any of our functions, in any of our if statements, in any of our loops, or anywhere in this program, we can access the controls.
Yeah.
Otherwise, you really have to sort of think about where you're accessing the controls. If you make it something that you only do in the main loop or something like that, you might have to have everything in one particular function, and it's just kind of nice to have the option, even though you probably do want to keep it all nice and locked down and restricted, but I really like having the option. So that's the controls. They'll be updated in our main loop. We'll come to that. Then we've got a vector, a three-dimensional vector for our camera. So this is an X position, a Y position, and a Z position. Now we're in 2D, so the Z position isn't a Z position in the sense of 3D. It's a zoom. It's how close the camera is to our 2D surface that the game is playing on, right?
Yep.
And so we're using the set sprite camera function to just put that initially. We're putting the middle of the camera in the middle of the game world. So we're saying, I want the middle of the camera to be looking at game world position 0, 0 on the X and Y axis, which is just the middle of our map. So starting it off nice and centered, basically. Then we've got our player setup, in which we are creating a player by using the create sprite function. So we've got a sprite variable. Then we're using some of the sprite functions to set up that sprite. So we're assigning an image to that player.
And that's referring back to the image we loaded at the top, is it?
Correct. Yeah, exactly. Yeah, that's the player image variable there. And we're also setting the scale of our player to be half the size that it is by default. So that's that 1, 1 in brackets there is the X and Y scale. And then we're multiplying both of those numbers by 0.5. So we could just say 0.5, 0.5, but we've just kept it simple and just done, 1, 1. So we get the default scale times half.
Yep.
So it's actually half scale. So underneath this, we've made two properties. And these are properties that don't exist before this. So before we make these aren't properties that exist in our player sprite. Sprites have a bit of a special behavior in FUZE, which is that they have all of these special properties. They have these default properties. So, for instance, if you just make a line above that, Dom, and you write player.x equals 100.
Okay.
When you do that, right, .x is a property that exists already in FUZE. It's a special property. When you do that, it actually changes the position of the sprite. You don't have to then do something special, draw it somewhere else. It's not like a normal variable. Sprites are special. They actually have special behaviors. So the .x, .y, they do move the sprite, but the vel_x and vel_y, they don't exist. We are creating them when we do those next two lines.
Right.
Now, knowing which ones are default properties, which ones exist already, which ones don't, that just comes down to experience and practice. And there is, of course, a list of all those in the FUZE documentation, so you can double check. But generally, everything to do with position and scale, they're the things that you get by default. Everything else, you can create one for yourself. So, for instance, we could do player.health equals 10. and then we could use that later on in our program.
And that's one that we've established in this code.
Yeah. So if you do player dot instead of x, if you write health, player dot health equals 10. So now we could later say if player dot health is 0, then we make a game over thing happen or something like that. Right, and then we could be reducing things from that player health. I mean, we could also make separate variables for them, but it's quite nice to have everything contained in a sprite because it's just all of its things are in one place. So yeah, they're the properties. Now the vel x, vel y stand for velocity x and y. We're going to use them to move the player in a satisfying decelerating, accelerating manner, which I believe is covered in our player controls. So we can go down to our main loop now. And we've got the general layout of how we want a main loop to look, all things gone well, which is that the first section of our main loop is the game logic. So, like it says, updating everything, checking things, doing stuff, calculating things. And then the second half of the main loop is that we go through and we draw everything that we need to draw.
And in this context, what does drawing mean?
It means drawing things on the screen and making them appear.
Okay. So things that we're going to see as players.
Yes. Yeah. Any of these, there might be another handy thing I can discuss here actually, but it might require a slightly different type of explanation. Hold on, let me see if I can. I need to just be very awkward. Oh.
Just while Dave is doing that, I will also answer Kirby Super's question.
Yeah.
I mentioned it in the chat, but Kirby Super asks, does Fuse have a sprite editor? Yes, it does, and we had a little play with it last time. I did make a perfect work of art in it, so if you want to check that out, I don't know whether we'll necessarily be looking at it today, but you could go back to the last stream we did together to check out the sprite editor and some of the features that it has to offer.
Indeed.
Yeah.
Now, not that, but this. Okay, if you swap over to my screen, Dom.
Yep. You ready for it now?
You can see this this page that I've got here.
There we go. We've got Dave Cam.
And you've got all the other bits and bobs on my desk that I should have taken care to clean up. Okay, so there's something that happens which is kind of implied, which isn't very obvious, and I want to make sure that you're all getting this. And don't worry about the quality. I'm going to draw just 2 boxes, basically. Okay. So let's say that you've got your switch here. This is the switch that you're seeing, yeah? And we've got the screen. Now, when you do any drawing command, like clear, draw map, draw image, circle, box, anything, any draw command, you're not actually drawing it on this screen. What you're doing is you're drawing it on a screen that is in the computer's memory. Okay, and this has a name. It's called the frame buffer. And whenever you do draw sprite, right? So let's say we draw Mousey, and it's going to draw on this imaginary screen.
Yep.
Okay. And then when you do the update command, what it does is it sends this frame buffer to the screen. Okay. So when it reads update, it says, okay, take the frame buffer, which is just an image like a canvas, and actually send all of that information, all those pixel values, to every single pixel on the screen.
Right.
So the frame buffer you can think of as like a little separate little drawing area. And what's cool about this is we can make our own. We can make our own images, draw to them instead, and then collate them, draw things in a particular way, put all of that on the frame buffer, and then put this on the screen. So, for example, we might have like the game and the character on one layer, then we might have a mini map on another layer, we might have a heads-up display on the layer over that, all on separate screens, and then we sort of collapse them all onto our master, put that on the frame buffer. When it reads update, it all goes on the screen, and we can see Mousey with his whatever, and we've got a cheese counter, and we've got a mini map or whatever it might be. Okay.
Yeah.
We might get into that as we go, but it probably isn't going to be something that we look at today. But in the spirit of sort of explaining everything that's happening properly, when we read, clear, draw, do this, draw map, draw image, this is what's being drawn to. When it reads update, it all goes to the screen that you can see.
Amazing. Okay, that's great to know, and I think that has reminded a few folks in the chat of ways they may have seen something similar in the past. So Kirby Super says, "Oh yeah, I made a game in Scratch that took advantage of the frame buffer, where the sprites were set to hitboxes. Then I checked collisions, and then I cleared and actually drew the game's graphics." So I think that's the frame buffer and drawing before you actually send it out to the screen, if I understood correctly.
Yeah, I think that does make sense. Yeah, he's taking advantage of the frame before the sprites set to hitboxes. Yeah, because you can use it to like have all different sort of things drawn to different layers, and then you worry about sort of moving them around later, or because it just gives you more freedom.
Yeah.
If you're drawing everything on the same canvas all the time, then moving things around becomes a little bit more, or changing that later becomes more difficult. Whereas if everything's on its own, it is literally why people use layers in image editing software.
Yeah, I was going to say, the thing that it really reminded me of is having layers in Photoshop, for example, where you can make changes to those layers and it not affect the overall image that you're seeing on the canvas as the output. That's a beautiful comparison for me as somebody who's more familiar with that.
I think that will resonate with a few people, actually.
Yes, definitely.
And certain effects are only possible by using these separate draw targets. They're called draw targets, is what I'm talking about here.
Okay.
They're layers, draw targets. Certain things are only possible by doing that. When you need to clear one draw target but not clear another target, so that you're leaving a trail on one but not the other, this sort of thing is where that sort of thing gets brought into consideration. Okay, right, without going on too much of a tangent. So that's the end there. So when I say drawing, when we say game drawing everything on the draw target that we want, in this case, the frame buffer, and then sending that frame buffer over to the screen so we can see it with update. And then we've got our player controls. We've got our game functions, a space for all of our game functions. So small sections of the program that are going to do their thing. We can keep it nice and organized. Sometimes these are totally self-contained things that do things in a different way. Like go and get information for us. Sometimes it's just a list of instructions that we want to keep nice and clean somewhere else in the program. In this case, we started off with the player controls being nice and organized into one area. So it's a good thing to do. It's really good practice to get into, is to think functions first, always, because then you're just sort of being neat and tidy from the outset, and it becomes easier later.
Right.
So the overview there is that, that's kind of the overview. Just to break down that player controls, we're taking left stick X and Y values, so the left and right position and up and down position of our left stick. We are taking those values, which are between 0 and 1 or 0 and -1, depending on which way it's pointing. If it's pointing to the right, we're going on, we're pushing towards 1. If we're going to the left, we're pushing towards -1. We're taking those numbers, multiplying them by 0.3 to sort of make them lower, so we're not really accelerating super quickly. We're adding them to those velocity variables, and then we're adding those velocity variables to our positions, and then we are reducing those velocities by an amount. So in this case, we're reducing them by 17%, or we're timesing them by 0.83. So every single time it does this, when we let go of the stick, we're gradually slowing down at a particular rate. And then the last part is some fancy maths to calculate the angle that we need to point the character in, depending on the way we're pushing the stick, by using the atan2 function, which simply takes an X and Y position and gives you an angle around an imaginary circle, really, to represent where that is pointing.
Yes.
There's no point in going into the trigonometry of that here. I think it's just going to alienate more than it will help. I like to think of functions that like this, these maths functions, very practically. All you need to know is what they need, what they give you. If you really want to look into the maths, then fantastic, more power to you. You should totally do that. But I don't want to scare people away, because you do not need to understand the maths behind it to actually use it and get the effect. All you
Yeah.
need to know is, I know that Atan2 gives me, the right angle of rotation. So if an angle of rotation is what you need, and all you've got is an X and a Y to point in, Atan2 is what you need, and that's
And now
helpful.
in our specific case, we were using this to allow Mousey to rotate, because before we were able to move around the screen, but we were only pointing in one orientation. Is that right?
Exactly right.
Perfect.
Exactly right.
Okay.
Yep.
And Atan2 allowed us to get that rotation there as well.
That's right. So and Kirby brings up a good point. So pretty much the position to angle node on in GBG, I imagine that is exactly correct. It
Okay.
sounds like exactly what Atan2 is doing.
That
And you might
sounds-
think, well, why is it not called position to angle? And there's a really good argument to be had there. But Fuse is in a position where we want to do two things. We want to make it accessible, so you can so you're not intimidated to try new things. It's not giving you loads of all these errors that are really niche compiler errors and stuff. But we also do want to tempt you towards learning the maths and improving your abilities. I mean, it's only by using these functions that I've learned what they do, and even think that I could begin to understand some of the maths behind it. And if it was just called position to angle, then I might not really think about that. I might just go, oh, I want this, and that's what it does. That can be all you ever engage with it, and that's fine. But it's pretty cool to know that that's what Atan2 does, and then you can go and dive even deeper if that's the way you want to go. Anyway, question: is rotation a default value in Fuse? Good question, Kirby Super. Yes, it is. Yes, it is. And you can kind of tell that. I think you've got the good intuition there, because we haven't already defined it anywhere else.
Yeah, we didn't see anywhere previously in the code that was us establishing player.rotation.
Exactly, and it's going to do something, right? It's actually making it rotate, so it's a really good question. Okay, right, that's the recap of all of our bits and bobs there.
Beautiful. So we're remembering what we've established already in the code here. We're remembering a little bit which functions we've set up and defined ourselves, and generally where the project is at this stage. So
yes, so we're in a good position to keep going.
Yeah.
I think.
Should we remind ourselves how this looks on screen as well?
100%. Oh God, I can't believe we haven't done that already. Actually.
Let's give it a go. So it's easy enough to run this. It's just a case of pressing the plus button, and we are straight in, and we have a little test map. We have player rotation and movement, and as Dave was talking about in the recap, we have that lovely kind of ease in and ease out of the movement. So Mousey doesn't just stop on a dime, so to speak. There is that little bit of momentum, or a sense of momentum in the movement.
Let's double check our collision as well, Dom. Let's see if it. Yeah, great.
We've got
hitting there.
We've got walls that we can collide with. I forget how we got these set up. I think these have got collision current. Oh no, nothing at all. But when we were in the map editor, we did talk about the ways that we could kind of set up spikes as their own defined sort of collision.
Yes.
Yeah.
Exactly. Yeah. So the code is kind of there in the program, but it's switched off. So we're saying yes, we want to collide with the spikes, but we don't want it to actually push us, or for us to push them right now. We just want to ignore that, but maybe we'll do something later with it. Because it will tell us that we are colliding with them, but we're just saying we don't want to be pushed by them at the minute.
Yeah, we're essentially just not kind of actioning that, for want of a better word, in the code.
Yeah, exactly. Yeah, very much so. And Mouse is looking really good and totally not disgruntled.
Very normal.
Just a totally normal mouse.
Just a normal looking mouse.
It's got no issues at all at home going on.
I don't even know why you would even mention that, Dave, because it is a completely normal and healthy looking mouse.
It's so healthy. Just take that to the vets and just sort of drop it on the table, and they would just like look at you and just say, "What have you done?"
It's honestly merciful we don't have spike collision. I think it would have been a step too far. So, what comes next at this point?
Good question. So, what comes next is, in the spirit of testing things out still.
Yep.
Because we've got a test map and we've got some testing stuff. Before we start worrying about, right, let's make a level, let's go full bore into the creation of our actual game properly. I'd like to do some more proof of concept stuff with some mechanics.
Okay.
The more you can do of this, the better, because it will inform how your levels eventually work. And when you come to doing the stuff that's meant to be concrete, it's going to be better if we have a good idea of how fleshed out our mechanics are and how they're going to work.
Yeah, because I think... Oh, sorry, Dave.
No, carry on.
I was just going to say, because I think a lot of people are familiar with the idea of like a test room or like a developer room or, you know, quite often in games, they end up getting left over. As somebody who's always interested about the kind of cut content from games, it's one of the things that we hear a lot about. And I suppose... you know, when we're dealing with this, it makes sense that they would have a little test environment to make sure that the mechanics and the way that the game behaves is exactly as expected before fleshing out this whole kind of interconnected set of maps and all of the art assets that are going to need to be generated for that. Having a little space to just test things out and make sure everything's working right. And also even seeing what you're going to include, I suppose. Yeah, it's good to get those all really solidified before you start making maps that you then might have to tweak. If you went in and, you know, suddenly Mousey can jump and you've made 20 maps and you haven't defined that ahead of time, then you're going to have to go in and tweak every single one of those 20 maps.
Exactly. So let's do... good. Right, so we're totally on the same page there.
Great.
So with the proof of concept stuff, I'm thinking... So in this game, we're going to want some sort of collectibles. Now, I know we want cheese. But the more you do this sort of thing, the more you start to think ahead, because we could make cheese as just one array of cheese sprites that has its own behavior defined, and then later on we decide now we want some, you know, other things to pick up. Maybe we want like obstacles, like mouse traps or something. Heaven forbid. And then we're going to have our own system for those, another array of different things that we have their own behavior. And what you'll end up with is every time you want to add something, you're kind of reinventing the wheel every single time.
Yeah.
And so instead, what we're going to do is to look at a way to kind of bake all of that into the very beginning. So we're going to make the cheese pointing sort of towards the ability to make other items later.
Okay. Yeah, so we have those as kind of like a basic item with room for it to become something else. We're establishing that right from the get-go in case there is additional types that we want, rather than having to reinvent the wheel to add the next kind of item.
That's right.
Makes sense. That seems really, really smart.
Exactly. And so to do that, first, what I'd like to do is to make a couple of general, sort of very generic functions that can be used for us later. So what we'll do is we're going to make a couple of functions, and the exact use case might not seem immediately obvious, but, you know, let's sort of trust in the process and we'll get there.
Absolutely.
So we're going to make a function which just creates a bunch of blank sprites, and just returns them to us. And these blank sprites are then going to be used later on to create things in those slots.
Okay.
So we'll go... Later on, we'll sort of go over these arrays and say, okay, go and get me a slot from this bunch of blank sprites. And then when you find one, we'll turn it into something. Now, this will just essentially save us having lots of arrays with lots of duplicated code, lots of for loops, setting them all up. Now, obviously, we could do the bad way first, then do the good way, but I'm going to sort of, in the interest of getting, you know, plenty done, making some progress, let's just go right ahead with this function. So we need to make a function. And this can either be before your main loop, it can be afterwards. We could end up moving it anyway later on, because that's the benefit of using functions. But you might as well keep it in the bit below the main loop, where we've got the rest of our game functions.
Yep.
Yes. Okay. But actually, I'm going to be really annoying and say, go back up to the global variables. Because before we make this function, what we're going to need... this is a really, really nice way of doing this, and it's not something that is in a lot of the FUZE programs, but this is the way that sort of implicitly recommended by the person who wrote the Sprite system, and so they. This is a very nice way of doing it. It might be a bit tough to understand at first, but once you've got it, it's very nice and clean. So we're going to want an empty sprite for us to compare against later. We're going to call it null or empty sprite. I like null sprite. It's something that you'll see a lot in various parts of Fuse, so we might as well do that. So if you could make a variable called null sprite,
Okay.
all one word, and you could put a capital S just for the sake of.
Oh, yes, we've got a camel
lovely
case. Yes.
camel casing. And into that, we're going to go equals create sprite.
Without a space?
That's correct. Yeah, create sprite, our function. So it's going to need a pair of brackets, just as it is, like that. Okay, so this is it. That's all we've got.
Okay.
What we've done there is we've made an area of memory, which is a sprite. So it has this identifiable thing about it. But you can think of it like an address, right? Sprites aren't really they're not really objects. They're not really like a thing. It's more like an address directly to where this piece of memory lives, where, we can have all these different bits of data associated with it, like its X position, its Y position, its name, it's this and that. So this one is like an address to an empty house.
Okay.
And then we're going to use that address to fill these arrays with nothing. And then later we can go, if when you're looking in this array you find an empty house, populate it with something and turn it into a filled up house with stuff.
Okay.
But it's really, really helpful to have this. So we've got our null sprite, right? Now at the bottom of our code, back in our functions, let's have a function called, I like init sprites or empty sprites, or it's up to you. Really.
Shall I do it here or
make sprites? Yeah, that's fine. Absolutely fine.
Init is funny to say, so for that
it's
reason,
also something that gets used a lot. I mean, initialization is sort of a key term. So you're going to want the function keyword at the beginning as well, because we're defining a function here.
We've got function.
Yep, init sprites.
And
we'll do sprites with with plural because we want it to be an array. This is going to return to us an array of sprites. Now, what we might want to put in the brackets, as you're correctly intuiting here, is how many we want. So let's call this a variable like num. So this is a local variable that only exists in this function. It will become this variable when we actually use the function. So at some point we're going to say like items equals init sprites 64.
Yep.
And it will make 64 blank sprites for us. Yeah.
Right.
So after this, on the next line, let's say return at the beginning of the line, because this is going to be the end of the function. I'm just sort of doing the skeleton first.
Right, I see. Yep. So we're getting the top layer of bread and the bottom layer of bread, and we'll fill in the sandwich in a minute. Okay. Yep.
Exactly. That's right. So we do return. It'd be really weird to make a sandwich where we get the top piece and then we do it all downwards from there.
Oh no!
Just keeping it all on the countertop. Yeah. Until we get to the last bit of bread.
Yeah, we're buttering the bread. We're getting everything ready right now. Exactly. We don't want any loose bits of lettuce or ham just on the kitchen counter. Exactly.
Lettuce and ham. So we've got a return. Now we're not going to return void. We actually want to return something to us, but we haven't made anything yet. But we will call it sprites. Okay, so just put return sprites. We're going to make a bunch of sprites. We'll return them here. So now inside our function, we'll tab in, so we are, looking nice and clean. Yep. That's it. And we're going to define this sprites thing as an empty array. So sprites equals open and close square brackets. Equals open and close square brackets. That's all right. Yep. Okay, so now we've got a thing, right? Now it's returning something to us. It's just returning an array with nothing in it, which isn't super helpful. But at least now it's a valid function, right? This will work. It's not going to say, hang on, sprites isn't a thing. I don't know what you're talking about. So next line, what we're going to do is now we're going to populate this array with num amount of empty sprites. So to do this, we're going to need a for loop. So for I equals 0 to num loop.
For I,
yeah, the variable, just a bland old index counter variable. Could be anything, but I is the conventional one because it's short for index, and we use it for indexes a lot.
okay.
So for I equals 0 to, so that's the number, the word 2, yeah, to num. So we're making a for loop that's going to count up to this number that we pass in its sprites.
So just to make sure I'm understanding here, this
Yep.
for loop here. So we're saying between 0 to num, but we haven't defined num currently.
That's right.
Okay.
Num will be defined when we actually use this function.
So it could be
It's
0
sort
to
of thing-
10, it could be 0 to 64, it could be 0 to a million.
That's right.
But we're just leaving num as at the moment, and that can be.
That's right.
Okay,
Exactly.
Got it.
Exactly. Now, if we were to, when we use this function, if we were to say in its sprites and then Dave in bracket in speech marks,
Yep.
then we're going to get an error
Hmm.
because it's going to say, well, hang on, I was expecting a number,
Yeah,
but I got
yeah.
a string instead. So back to our little point about interpreted and compiled languages, Fuse allows you to write this function not even knowing what num is going to be, because when it gets there, it will interpret it and figure it out. But a compiled language will say, hang on, you cannot count up to a thing that I don't know what it is. What
Yeah.
is it? Is it an integer? Is it something else? Is it? So you'd have to actually say what num is going to be.
Got it.
Just to paint more of those, just to connect some more dots there. Anyway.
I just want to take a moment to read out Arch's comment. Arch, good to see you in chat. Arch says, "Oi, Dave, great to see you have Dom on your stream again." Also,
no, I'm talking too much.
no, it's perfect.
I know.
Nat, great to see you in chat as well. Nat says, looking through all the Fuse workshops for school. So cool.
Oh, that's awesome. Thank you so much, Nat. That really means a lot.
Yeah.
We are very proud of our Fuse workshops, and the kids love them as well. So great stuff. Thanks for noticing.
Arch also had no idea that Dave was a string.
And that's a teacher. Very cool. Excellent.
And we're jumping a bit further ahead than you would do typically in your introductory workshops. Is that correct?
Very much so. Yes. Yes, this is not what we would do in the introductory workshops, but it is definitely, I mean, this is the thing, like Fuse could pack multiple terms worth of content if we wanted to, if we were given the opportunity to. It all just matters on what the school can work out with us. But yeah, absolutely. The amount of content is essentially infinite. We can just do, we could cover all the concepts from now up until A level or whatever it is, with lots of projects as well in between. But what you're seeing now is far more advanced than we would do typically with the first workshop. Yeah.
Wonderful stuff.
Okay. So for I equals 0 to num loop. And then let's put our repeat in there. Let's get that bread within this bread.
That's
going to go underneath.
Just underneath, but it's not indented. Is that correct?
That's right, yeah, because the repeat signifies... Oh, no, it is indented because we are still inside the function.
Yeah, of course. Yeah.
So everything inside this loop will be indented one further. Each of these layers of indentation, each of these levels is what we refer to as scope.
Okay, yeah.
Whenever we change scope, whenever we enter a function or an if statement or a loop or etc., that's when we indent. And when we unindent, we are returning to the scope that we were in before. And scope does go a lot deeper than that. I'm only just sort of putting a name to a face, if you like. Really, it has a lot more to do. It has a lot more going on. But that's, just to give you another term. Okay, so inside that loop, though, now.
James Morris's analogy in chat. So a Big Mac with bread in the middle is
exactly
very nice.
Exactly.
Sorry, Dave, go ahead.
So in the middle of this for loop, so in between for loop and repeat, in there we're going to indent and we're going to say sprites I. So sprites in square brackets I, sorry.
Ah.
I beg your pardon. So sprites I in square brackets.
Oh,
yeah,
yep.
I beg your pardon.
Yeah, that was
So
all me, Dave.
no. So if you get rid of that space, not that you need to, but just because this is the array.
Mhm.
So what we're doing here is we're saying, right, I want something in this array. Now Fuse lets you do this thing, which not all languages do. Again, it's just for simplicity's sake. It lets you index slots in the array that don't exist as long as you're putting something in there. So you'll notice because sprites is an empty array, it hasn't got anything in it.
Yep, as defined up here, or as we're seeing up
Exactly.
here, I guess
But
I should say.
Now we're saying, well, let's say that I is 0. Well, now I want to get the first thing in this array. And you should think, well, hang on, there's nothing in the array. So surely that's a problem because I'm asking for something that isn't there. Now, it's okay because we're going to put something in there. If I was going to say print sprites I, it would say, I can't do that because there's nothing to read.
Print. Yeah.
As long as we're writing to it, it will let you do this. And so it's a very easy way of just adding to an array. We're just adding to the end. Think of it like that. We're just putting something in, moving along, putting something in, making another slot, putting something in. Okay, so sprites I close bracket equals, so at the end of this line, space equals, and we're into this, we're going to put null sprite. Right. And then if you get rid of that space on line 54, and we're done.
Okay, so
now we've got a function which will create any number of blank empty sprites. It'll give us an array with a bunch of slots in, and each of those slots points to an empty house.
Yep.
At any point, we can go through any of these arrays that we make. For example, let's go back up to the top of our program, actually.
Could you remind me the quick way to return to the top, Dave? I couldn't...
If you double tap home on your keyboard, if you've got a home and end key.
I don't think I have a home key. Okay.
You can use page up and page down.
I'm using a short keyboard this time, which was a mistake. I'll do it the old-fashioned way.
You can, if you hold down. Okay, so if you've got all those different problems in place, then you can hold down ZL and use the up and down arrows on the D-pad.
There we go. Yeah, I think that was
that
what
will hop
we used
between
before.
Functions or the top of the program.
Perfect. Yep.
Yeah. Okay, so now in our global variables, the very last one, because we want to do this after null sprite because we're using null sprite. So make a couple of lines. That's it. Let's say we make an array called items.
Yep.
Equals init sprites. And then we'll put like, I don't know, 100 something. Who knows?
Okay.
Right, so now we've got an array called items, and that array stores 100 copies of this empty null sprite.
Which is here.
Yeah, that init sprites function.
Yep.
So even though we've called it sprites there in that function, it becomes whatever we, name the thing that we're using it for. So we're saying this is actually what we really want to call it, items. And into this, I want to put whatever we get back from this init sprites function. So give me 100 of whatever this function, gives us. We're giving it 100. Go and do your thing with that number and give me back whatever we want, which is an array of 100 empty things. Now, this is so good because let's say we wanted to have some enemies later in the game. And we want to initialize them in the same way. Underneath this, we could do enemies equals init sprites 10. Or later we could do, obstacles equals init sprites 5 or anything.
Yeah, right.
Now we don't have to write this for loop that gives us all these empty sprites ever again. It's just done for us with a function, which is very, very handy.
This really reminds me of something we looked at, I think it was 2 streams back now, where we were making our little multiple choice quiz. And we went through in a really lovely way the kind of most straightforward way that we could write it, which was great for just kind of understanding that once. But then we learned how to kind of refer back to that in a much more streamlined way. And you know, we kind of built up on that knowledge, didn't we? And we came to end up having a really succinct bit of code that did all of the stuff we needed to do. Yes, Arch says the Quizzard. Yeah.
Indeed, the Quizzard. How I miss the Quizzard.
Oh, we got to see the Quizzard
Simpler
return at some
times.
point. Yeah. So yeah, we could say Quizzards equals init sprites.
You could
100 at some point.
You absolutely could. You'd have 100 Quizzards.
And
well, you wouldn't actually. You'd have 100 nothings.
Yes,
But
right now.
the
Yeah.
potential is there for Quizzards.
So
Quizzard for life, indeed.
Yes, Quizzard for life. Where did I see it? Yes, James Morris said, so null sprites are like adding empty slots to be filled. That seems like exactly the way to think about it.
That's exactly right. Yeah, exactly right. It's
our items equals init sprites 100 here is making 100 nothing right now.
Yes.
Yeah.
Yes. Yes. Now the reason we do it that way is because of there is there's sort of a convention. There's like two things that you have to do whenever you want to have like multiple things all happening at once, like multiple items or multiple enemies or things being spawned and updated and then leaving and this sort of thing, which is just such a big win when you when this sort of clicks. It opens the door to making a lot of things yourself. And it's the same concept all the time. Now I do these holiday workshops, did one yesterday, where I will sort of build the game on the fly with the kids at the workshop, and we'll say, right, get a whiteboard out, what are we making today? And they'll just come up with ideas, and we'll draw the game screen, we'll get some ideas going, we'll say, right, top down sort of twin stick shooter with 2 players that can blah blah blah. And I'll teach them sort of the value of, don't proliferate ideas past a proof of concept, but let's try and keep it nice and simple. And we'll do that, and then we'll just make the game. And I will write the code, and they'll copy it down, and we'll talk about what we're adding, and we'll discuss the things, tweak things. They'll all have different things by the end. But all the code is basically the same. And the reason I can do that on the fly and just make whatever game they come up with within reason is because I just know like a handful of tricks, and these tricks can be used to make anything. They're so helpful. You can make so much stuff. So most things that they want to make involve some sort of items or something to pick up or some sort of shooting or platforms or whatever. Multiple things doing things. And in order to have that going on, you need arrays of sprites moving around, doing stuff, being checked and updated. In order to have that, you're going to need creation and updating. So you need 2 things going on. You need to, at some point in your game, you need to create the thing that you're talking about. And then you need to update them. So check them, check what they're doing, move them around, blah, 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 spin them around, rotate them, collide with them, etc., etc. So these 2 things, once you get this idea of creation and updating, you got to create, you got to update. Once you get those 2 understood of how to do it, it all opens up. Now, you can do that in the way that I'm talking about, before, where you've got sort of like lots of different arrays and loads of different creation functions and all sorts going on. You can learn some more efficient ways of doing it, like with these functions, but the idea is all the same. We're going to create some stuff, we're going to update some stuff. Okay, so that's where this is leading. Now, this method with the initialization of some null sprites is what I think is the most effective, efficient in terms of the Fuse language, and it involves just less typing. It's an efficient way to keep track of all your sprites, James Morris, yes. So how do we fill these empty slots? How do we fill these empty slots?
Okay, well, we're going to need to create, aren't we?
We're going to need a create function, and we're going to need to, when we create, what we're talking about is we're actually talking about going into one of these arrays of items or whatever it is and finding an empty slot. And then when we find it, we want to set a bunch of stuff to that. So we're going to go, okay, instead of it being this blank thing, we're going to make a new sprite in its place. We're going to give it an image. We're going to assign its properties and whatever. Yeah. Now, we could have separate functions for creating a cheese, creating whatever other item we might want to make. My mind fails me right now, but
Yeah, a pair of boots that make us jump super high, for example.
I was thinking of shoes. That is so weird.
Interesting.
That's weird. I was going to say cheese, a shoe. It was like, why would you want shoes? And you actually gave an actual reason, which is I'm really grateful for. So yeah, exactly.
Or run super fast.
We could have separate arrays for all of them. We could have separate everything. But I want to show you this method of sort of looking a bit more professionally, or at least a bit more forward thinking.
Yes.
So let's say we want to delineate between all these different types of things. We're going to have items.
Yep.
They could be shoes, they could be cheese, they could be whatever. So we're going to want something called an enum, which Fuse doesn't really have like a what's the word? Like an infrastructure way of doing this. This is a coding concept that you see all the time in other languages as well, but in Fuse, you just sort of make a bunch of what it means is an enumerated set of things. Basically, a bunch of separate numbers. That's all we're talking about. So an ID for these different things.
Right. Okay. Makes sense.
So up at the top of our program, which is generally where these enumerations live in a program, right? We're going to go very, 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 very top. I like to do this above any loading everything.
Okay.
And they generally look like a word underscore and then another word. So let's say item underscore cheese.
Okay.
Right. Equals 0. Now we might want item underscore something else equals 1. Right? Whatever you might want it to be. Boots that make you go fast. Let's do that actually. Let's do boots. Yeah, it's a good one. Equals 1.
Okay.
So it's just an ID. We just need, and then the more of these we make, we're just going to keep going through and say, okay, like this one will be 2, it'll be 3, it'll be 4, it'll be 5.
Yeah. So if
in other languages, sorry, go on.
I was just going to say, so if we get a cape, that's going to be 2. And it's kind of a reference of those, a label for those.
Exactly. It's just an identifier.
Okay.
It's so we can at some point go, make one of these a cheese. A boots. Make this. And then later on we can also go, if the item that we're colliding with is a cheese, or if it's a boots, or if it's this, then do this. If it's this, then do this. If it's this, then do this. Yeah. It also, a bit more sophisticatedly, can serve as array indexes into a bunch of data to identify stuff that we might want to store. So let's say we have all of our item data, like the images that we want for it, the effects it's going to have, the amount of HP it gives you, the sound that it plays when you pick it up, whatever else. We could put this into a massive array of item data, and we could get that data by using these identifiers. So that's a little bit further down the line. For now, it's just a way to delineate between stuff.
Got it. Dave, what should I comment these as so that it's something I can remember when we come back to this? Is there a convention for this?
Yeah, I would call them enums. ENUMS.
Like this? Or...
I would just do capital E, lowercase.
Gotcha.
Everything else, because it's short for enumerations.
Okay, yeah.
So when you enumerate something, you're just giving numbers to things. You could also call them types, like identifiers. It's totally, it doesn't matter. But yeah, enums, types, whatever it is, IDs.
Yeah,
they're all totally valid ways of calling it that. If you think enums is going to be a little bit hard to remember, then I'm totally fine with you calling it whatever you want. You can write whatever you want here, dude.
Or IDs.
Yes. Great. Perfect. All right.
Got ourselves a little reminder up there as well, if necessary.
Yeah. I think that's a good idea. I mean, they are also global variables, right? So we haven't put them in the global variables section because we don't want to clutter that with all of these things,
because this list could get very long potentially, couldn't it? Yeah, exactly.
Eventually we could have all sorts of different types of enemies, types of things. Obviously we're not going to, probably it's not going to be like the most incredibly long, magnificent game ever made. But,
if we
I shouldn't say
imagine-
that yet.
Yeah, I
Shouldn't
mean,
say that.
there's plenty of time. If we imagine that, you know, somebody's setting out on a game and they know that there's going to be a bunch of different collectibles, there's going to be a bunch of different enemies, maybe some other kind of hazards in the stage as well that's going to require its own sprite, this list could get lengthy.
Yes, 100%. So we just keep them all nice and separate. Now, in more advanced programming applications, like if you were to go and develop something on a normal, you know, IDE or any other application, you tend to have different files for stuff.
Right.
So you might have a whole file that stores all of your enums. And then you would just include that file in this program if you want to use them.
Got it. So you'd refer to that file within this one, and
yeah,
put it somewhere completely different on its own.
Exactly, yeah. But yeah, it'd be interesting keeping it all simple. Fuse just has one project file.
Great.
Okay, so that's our enums. Now we've got something to differentiate. So we can have a create item function.
And that would live here?
Yeah, sure. Actually, Dom, I'd put it above init sprites.
Okay.
Because we're probably going to refer to it more than we refer to init sprites. Init sprites is now actually pretty much done. Like, we're never going to go back to that function ever.
Nice.
So you could even put that at the very bottom, but it's all, you know, moot really. So we'll call this create item. And we're going to, we want this to return something to us. So but we also want to tell it what sort of item we want. So you could call this return item. And in the brackets for create item, let's put a type.
Literally the word type, or we're going to define a type?
Yep.
Okay.
Yep. Yep, indeed.
Oops.
Okay. Now, we'll come back to that. Okay.
Mm-hmm.
Can you make a bit of line? Just make a bit of space above this function. Sorry, below this function, because this is going to be another one of our very, very helpful sort of general helper functions, like init sprites is.
Mm-hmm.
And this is going to be called all over the place. Well, basically, for any time that we want to create a thing, we're going to want to get a free slot from whatever array we're talking about. So this function is going to be a little bit complicated, okay?
Okay.
So we'll stick with it.
Yeah.
We're going to introduce a new keyword. It's going to be called, we'll call it get free slot, or get null slot, or get empty slot, or whatever you want.
Okay.
I like get free slot, personally.
Yeah.
Or get empty sprite, or it's up to you.
Free slot seems to make sense, I think.
Cool. Okay. Yep. Get free slot. Function get free slot. Sorry.
Okay.
Defining another function.
Right. Now we need get free slot, all one word.
Capital case on the free.
Yeah.
And on the slot. That's it. Some brackets. Great. And this function is going to return a sprite to us. So if you just underneath this do return sprite. So not in the brackets. That's it. Return sprite.
Yep.
Okay. Now, what we need to give this function is an array. We need to give this function an array, and we need to say, can you give me back a free slot out of that array? Right? So we'll call the thing in the brackets sprites with
an
plural. So in the brackets for get free slot, sprites. So we're going to pass this function a whole array of sprites. For example, we might later on do something like item equals get free slot. If I'm not just later on, but very, very soon. We're going to go item equals get free slot items. And it's going to go and get a null sprite and give it back to us.
Right.
Okay, it's going to make a sprite in there and give it back to us. Well, it's actually not going to make a. It won't give us back the null sprite. It's going to give us back a new free sprite to use. So let's just in this function tab in, and first we need to define this sprite variable. So sprite equals null sprite. We start with the default nothing sprite, right? So first we say make a sprite that contains nothing, an empty sprite.
Mm-hmm.
And now what we'll do is we'll go and check all of the sprites that we've passed into this function. And we'll see when we find one, let's make a new slot and then make a new sprite, put that sprite in the slot and then return that to us. So we need a for loop and it's going to be for I equals 0 to len. And then in brackets, normal brackets, so len is a function, which is asking for the however many slots are in an array. So we're saying, tell me however many slots are in this sprites array. So put sprites in the brackets. That's it. And then loop at the end of this line.
Okay, so that's our for loop started and ended here from for to loop.
Yes, in terms of the value it's going to start at and then end at, yes. So it's going to count up to however many sprites there are in the array that we pass this.
Mm-hmm.
So if we pass it that items array, it will count up to 100 because we made 100 of them.
Yeah.
So at the end of this, we need to make our repeat line. So put a couple of lines of space. So we've got some space in the middle, that's it. And then tab in and then repeat. That's it. Okay, now inside this loop, let's tab in even more. So tab. Right, we need to now check if the sprite that we are checking in this array is empty, is containing that null sprite. So if sprites I in square brackets, and then get rid of that space as well.
Oh, yes, yep.
You've got it. This will all go in, Dom, don't we? You're doing incredibly well for someone who's written barely any code in their life, I tell you. You amaze me constantly.
Thank you, Dave.
So now we're going to check if that thing that exists in that place is equal to null sprite. But because we're comparing something, we need double equals.
Yes, yeah.
Remember from our quiz, we're checking if the answer equals the correct answer. So if sprite's I equals null sprite, then, sorry, on the same line, put the then, even.
Oh, my bad.
Yeah, you got to have the then. This is the first if we've written today, so you're forgiven. Okay, then on the next line, we'll have a space, and then on the line underneath that space, we'll have end if. Okay, and inside that if statement, right, this is what's going to happen if the sprite that we find is empty. So on line 62, tab in again, because this is what's inside the if statement now. Right, so if we find an empty slot in this place in the array that we're checking, sprite equals create sprite. So you can, we're basically, instead of our null sprite that we started with, which is the default one, we're saying if we find an empty sprite in this array, let's, instead of having null sprite in our sprite variable that we started with, let's make a new one that we can use, and let's put this into this slot. So put round brackets on create sprite.
Oops, wrong one.
And then underneath that, on the next line, we're going to put that into our sprites array. So sprites I.
Square brackets for that.
That's it. Equals sprite.
And that doesn't need to be equals.
Nope, because we're
comparing.
putting something somewhere.
Yeah.
Equals sprite.
Sprite, yep.
That's it. And now, the most key part of this, really, the most important part of the logic is that, well, actually, I wonder if you can, I'll give you a bit of a test here.
Oh, okay.
If we were to leave this as it is now, something really bad will happen. Not really, really bad, Like, it's not going to break, but something will happen that we really don't want. Think about what this is doing. Let's say that we want to get a free slot from the items array, right? Items is an array that contains 100 null sprites.
Yep.
This for loop checks every single slot and checks if it's a null sprite. And if it is, then it replaces that null sprite with a new blank sprite that we can now use. But the problem is that when we do this, because of the way we've written this, it will just replace every single sprite with another sprite. Yeah, because it's just saying, if you find an empty one, make a new one, put it in there.
Because every time it finds that, it's going to do that.
Yes. Every time we call this function, it's going to completely overwrite every single sprite in the array. Okay, that's not what we want to do. We only want to overwrite one sprite. So, after we do sprite I equals sprite, we need to make a line.
Yep.
And Borry has already he's seen this. We need this new keyword. It's break.
Ooh.
And it breaks out of a loop. It's going to exit the loop that we're in.
After it does it once.
As soon as it finds a null sprite,
Yep.
it's going to make a new one, put that new sprite into this slot, and then stop searching.
Okay.
And then it's going to return the address of that new sprite to us so that we can now do whatever we want to it, change it, make it a different image, do all sorts of stuff to it. So this function is actually very sophisticated now.
Yeah.
And it is a little advanced, and I do apologize because this is sort of where I've got to in the way that I approach making 2D games with sprites, and I believe that this is the most efficient way to handle using sprites, because what it means is that when we come to update everything, when we come to write the rest of the stuff, we won't have loads and loads of loops and ifs checking stuff.
Yeah.
Because otherwise, what I used to do is I used to have my blank sprites would be a sprite that had a .active property, and that active property started as false, and then I would always check if they're active. If they're not, then we make one and we make it active, which is okay. It just means that you have to sort of keep checking things again and again. Whereas this way, you just want to make sure it's not a null sprite, and when you want to remove a sprite, you just make it null, and it's really, really easy. But yeah, you'll come to appreciate how nice this system is once you see everything built. So we're making tools right now to then put into order and use later on. There is one last thing we need to add to this function.
Okay.
And this one is a little bit more complicated. It's one keyword, and it's called ref. And it's going to go before the word sprites in the line 58 brackets. So if you put the word ref,
the bracket?
in the brackets before the word sprites. If you put the word ref and then right. So this is one of these keywords that's sort of a bit more looking like an advanced thing, because we're changing the behavior here, right? When you pass something into a function, for example, Dom, when you put, that init sprites underneath,
just below, yeah.
You see that num variable in the brackets?
Yep.
When we pass this num variable, what we're really doing is we're making a copy of it, and that copy is called num. When we say make 64 sprites, right? That number 64, it's not the same 64 that ends up in here. It's copying it, and then we're using this copy.
Okay.
But because we want to actually change what's happening in the items array, and we want it to actually change what's happening in that array, we want to say, okay, change this thing, make a new sprite, put this sprite into this slot. So we're actually altering the original. Because we want to alter the original and not a copy, we have to say this array called sprites that we're going to pass in is actually a reference. It's an address to this thing rather than it's a copy. So we're not
Okay.
just copying the array of sprites and then doing something on something that we don't, really care about. We're saying I want to operate directly on the actual same memory that this thing occupies.
So we're not
So
using something that looks like that. We're not using we're not making a new 64. We are really looking at that specific thing there.
yeah, exactly. Yeah.
And we will be
Yeah.
making changes to that potentially.
And those changes will actually happen to the original thing itself, rather than, so if we didn't have that ref there, basically, it would never make a new sprite in our items array.
Mm-hmm.
It would make a new sprite in a copy of the items array, which is not what we want.
Yeah.
But when this keyword doesn't come up very often, and in fact, it probably won't come up again in the rest of this game.
Wow.
It's just that for this particular thing we want to do, you need it.
Yep.
We want to have it because we want this function to do something quite sophisticated, and the way we're setting this up, it needs to operate on that exact array. Now, we wouldn't have to have it if we were just okay with writing that exact same for loop every single time we want to create an item or an enemy or a whatever. But now we've got that, we can do this.
Yeah.
So, in our create item function just above that, we're going to go make a line, inside that, tab in, and we're going to go item equals get free slot, and then in brackets, items.
Okay.
So we're now passing the array of items that we made that's in our global variables.
Mm-hmm.
We're passing that into this get free slot. That says, okay, you've given me an array of sprites. It's a reference to those sprites. So we're actually talking about that exact bit of memory. We're not making a copy.
Mm-hmm.
And we're saying, okay, here's a null sprite. Let's look over all the items. If the item that we find is null, then make a new sprite in that, change null sprite that we had at the beginning of the function to a new sprite that we can use, and then put this brand new sprite into this slot in items. And since this is being called on line 56, that then becomes this variable called item. Now we've got this sprite called item, which actually exists in our items array as a newly created sprite in the free slots that we can access.
Gotcha.
And now we can do stuff to that, like make all sorts of things. And after this function, after this get free slot line, what we need to do is an if statement that checks if item not equals, so exclamation mark equals null sprite, then, and then end if, just get the skeleton in there. So yeah, back to the original scope. Yeah, brilliant.
Mm-hmm.
And then inside that is where we will assign it an image. We'll do everything else we might need to do. We'll turn it into what we need it to, what we need it to be. We'll set its properties. We'll do all sorts of stuff. But the reason we have to do that if statement is because let's say that there are 100 items in use when we say get free slot. Let's say we say get free slot and there aren't any items. There are no free slots.
Yeah.
Well, in that case, it will never do that if statement on line 64. And it will just give us back a null sprite. And so when we do item equals get free slot items, it'll just give us a null sprite. So we need to check that, okay, what we got back out of that is not a null sprite. We have a brand new fresh sprite to use, and we're able to carry on.
Mm-hmm.
Okay, this is the idea with the creation, and it is a bit complex. And explaining it all now, I'm starting to think, I hope I haven't jumped ahead by about two streams worth of content doing this. So I just want to reassure people, if this seems a little bit like, okay, I was with you, now I'm lost.
Mm-hmm.
That's very understandable, and I was exactly the same with this. But I really would just recommend that you just try it for yourself. Just watch the stream.
Yep.
Type it out for yourself, and maybe even make a note. Like, you need these things. You need an initialization. You need a null sprite. You need to create items or create things and get free things. Really, it's just about that init sprites and get free slot. That's it.
Yeah.
They're the two functions that you need. You can just copy and paste those into any program, and you've got a system which can make multiple sprites and do all that stuff, which is really cool. But it's like building a picture of how to approach managing multiple things in a way that's nice and efficient, and doesn't involve duplication of lots of different code all over the place. I'm starting to wonder, like, maybe it would be also very suitable if we had written this in a more sort of very beginner-friendly way. I believe in you all. I believe that you can pick this up. I really do. But it is a little bit tricky. So please feel free to ask any questions if you want me to explain anything again. And tell me if I'm moving too fast, because I don't want to do that.
Well, Arch in chat got a little bit ahead of you on this this section here and did predict get free slot. So I think it is a positive sign that chat is absolutely right there with you. And if there isn't anybody, or if there is anybody that isn't, excuse me, then as Dave says, feel free to ask some questions. We can recap any component of this. And in fact, I guess for my own sake, because this is definitely all brand new stuff to me, the initial init sprites was to establish our index. Is that the correct term here? And then we were using the get free slot function to actually find something from that empty set, and then we're actually creating an item from that, and that's referring back to the get free slot.
Totally right.
Did I use the wrong term there for this?
I think you meant array instead of index.
That's it. Yes, yeah, the array.
Yeah, but it's sometimes hard to tell because, like, an array, you use indexes to say which slot in the array you want. So it is like an array of indexes. It's kind of, but I understood what you meant, and you've conceptually outlined what these things do brilliantly.
I definitely don't feel like I could end this this stream today and recreate it from nothing, but having this here as a reference that I know that I could copy from and have a play around with, tweaking some stuff if necessary.
Exactly.
Yeah, I definitely understand. I've managed to keep pace in terms of why we're doing this and how this will be useful.
Great stuff. Okay, brilliant. Now, to really sort of complete the picture, inside our if statement on line 57, so if you make a line after that then, or before the end if, either way.
Yep.
And inside that, we're going to say...
So I'm going to tab in here, aren't I?
Yeah, that's correct.
Within the if, yep.
That's right. So we're going to check the type of the item that we're creating.
Okay.
So if type equals item underscore cheese.
Without capitalization.
That's right, yeah.
Yep.
Then, and then we'll make an end if after that. It was maybe a space if you want. And then everything inside here is what will happen if we say, create me a cheese, please. And we'll do that stuff and return the item. Which is really, it's really quite helpful. Now we have a dedicated place where we've got just all of our creation for items. We'll probably want a different create for enemies rather than having enemies be a different type of item. But you want to generally, my friend calls this collapsing differences. You want to try and destroy the differences between things.
Yeah.
Because it really cleans things up later. So we're sort of collapsing all these different types of items, cheese, boots, whatever we might want to make, into just one place where we can treat them all the same way as much as possible. Because if you have them all being treated differently, that's just more places where things can go wrong.
And in most cases, they will have more similarities than differences as well.
So correct. Like that's kind of what what determines that we want cheese and boots to share a thing. Well, they're going to appear in the level.
Yep.
We're going to collide with them and then pick them up.
Yep.
The only thing that's different is what we want to happen when we pick them up.
Yes, yeah. So collapsing the differences between those allows us to only define what is different between them.
Yeah, exactly.
Got
Exactly
it.
right. Yeah.
Got it.
Yeah.
That makes a lot of sense.
Brilliant.
Dave,
okay,
if this is
so-
a good moment,
Yes.
there's a few questions I can see in chat that might be good to address now. Because
Yes, 100%. But if I may just grab
Yes.
a quick drink, because I've emptied
yeah.
my drink here.
Yes, in fact,
Yeah.
well, let's do that. We'll come back. We'll answer a few questions before we move
Yeah.
on, but we'll take a drink
Yeah.
break now. Good shout, Dave. Actually, I need to
Okay,
do
great.
exactly the same. So let me bring
I'll
the
be
drink
back
break screen up.
in a minute.
Yep. And folks, if you
Alrighty.
want to grab yourself a drink, you've got a couple of minutes now before we get back started with this. So don't worry, you won't miss anything. I will catch you in just a few seconds for a minute. Hey chat, I'm back. I've got myself some water. I'm not sure whether Dave's back, but we can
Just sat down.
Hey, perfect timing. I was just gonna say we can hang out while we wait, but that's ideal.
Got a nice ginger beer.
Oh, that's crazy! I was about to get one. I almost got myself a ginger beer. I don't normally have ginger beer in, and I was like, should I get a ginger beer? And then I was thinking, I just need to hydrate. I literally, Dave, I literally never have ginger beer in, and
That's so weird. Oh dear. Have you had your tea yet? Have you had your meal yet?
I have, yeah.
What did you have?
Had a very lovely roast beef today and some
Oh, okay, roast
some
beef.
veg.
Oh,
Yeah. How about
I
you?
know I'm jealous. Actually. Well, I was wondering if you were going to say, because if we had the same meal, that would have
That
just
would
been
be
too weird.
too much.
It's I had this. I love making this. Just pesto pasta.
Oh yeah.
But
Yeah,
I
yeah.
make it with like all these veggies, so like leeks and pancetta and
Wow.
spinach and some double cream and like pecorino and parmesan cheese.
Oh,
and
that sounds delicious.
pretty good, Dom.
Yeah.
Pretty good. Not gonna lie, it's I enjoy it a lot, but it's probably quite calorific. But it's what you need.
Yeah, absolutely. Wouldn't have it any other way.
Steve, brand of ginger beer. It is shamefully just Tesco value ginger beer. So nothing fancy, I'm afraid. Okay, so did you want to have a look at a couple of questions?
Yeah. So I saw that Kirby Super in chat a little while ago asked whether Fuse can use some of the Switch's unique features, like motion control, for example. I did see that Steve's Gaming answered Kirby Super's question, but I wondered whether there was something that you can kind of specifically call out in the code as something to utilize, because I suppose in many ways it's a little bit similar to saying pushing left on the left stick, but you're just using a different thing as that to gather that information.
Yeah, I mean, it's part of the controls data. So
Right.
it is if you do, like, you know, when you do C.lx, C dot whatever, you just do C dot orientation or C dot velocity,
So
and
down
they
here, right?
yeah, like, that's where it would be. I think you've got the overlay for the brake on
Oh.
still, so I can't fully see.
Oh no.
But like,
So professional. There we go.
it's all right. But I could see the cursor, so I knew what you were talking about. Yes, so if you did like plus equals C dot orientation dot X, now that would be really weird, and it wouldn't. Motion controls are complicated.
Yep.
They are described with a set of 3D vectors. So orientation is a 3D vector that describes the way it's pointing, and velocity is a 3D vector that describes its velocity on the X, Y, and Z axes. But because they're so sensitive, you have to have sort of a window of acceptable value, and it's also very difficult to know which way it is currently calibrated, and they recalibrate fairly often, and they're hard to use. But people have done some very cool stuff. There's someone in the I just saw that comment. Get professional streamer.
Oh, that's gonna fail every time you try and run it.
Oh, it's silly me. That's funny. You got a funny community you have, mate. Honestly,
Oh, 100%.
makes me laugh. You got a good group. I think that our communities mix very well, actually.
Absolutely,
to be honest.
yeah. It's so nice to see.
It is as well. It's a good Venn diagram. Joy. Yeah. So on the is it motion? Yes, and IR no. Not yet. I'll say that.
Okay.
Okay. And is there code like this in code reference? There's no code that's exactly like this in the Fuse help documentation. And I'm going to be perfectly honest, the reason for that is because when I wrote a lot of the Fuse help documentation, I just didn't fully really understand some ways of doing things. And I was actually writing it very much from the point of view of like someone new to coding. So it both helps and hinders in a couple of ways, because it will take you through the good beginner's way to like approach these problems. But the thing is, I didn't feel like we needed to, and that's because there are games in Fuse that you can look at that do use this system. So the Super Mega Arena Blaster game, which is probably the most complete professional looking game that exists in Fuse, that uses this exact system. And that's very much why I'm promoting it here, because that game was written by Will Tice, who wrote the sprite system in Fuse, and therefore it is straight from the proverbial horse's mouth, really. And so I am also passing on the contents of that horse's mouth.
Like a mother bird.
That's right. Like a reverse mother bird.
Oh no.
Receiving from the mouth of the horse and giving from the mouth. As one horse unto another.
You can lead a horse to water, but you can't make it use the correct sprite conventions. Nice. So yeah, we're getting some.
Oh, that's funny.
We're getting some real best practices here from the person who wrote the sprite system for Fuse.
Oh, dear me.
Okay. Do you need a moment, Dave?
No, it's all right. No, you gave me a moment with that professional line. I was just smiling a lot.
James Morris says, I wonder if these techniques could be used in a 3D environment. I mean, I presume referring to 3D games.
So the so the sprite system is 2D only, and the idea behind this, you could write something very similar, using the same ideas to make something like a little 3D spritey system. But it would take a lot more work, because when we do create sprite, that's doing a lot of heavy lifting for us, where it's creating a unique type of data object in Fuse. So if that create sprite thing was like our own function that creates a new 3D object that has a bunch of data that we've already predefined, then yes, you absolutely could create something like this.
Right.
And I would recommend that you do so, actually, because it really does help. It's, you know, it's also something. It's a great thing to have just in a project without any other code in. Like, I now have these functions in a project that's just called sprite functions, that whenever I make something new, I'll just copy them. I'll just copy that project and then rename it. So I've already got those functions.
Right. You got them as a little snippet pre-set up.
Yes. Yes, indeed.
Nice. I just spotted one here, and Dave, you might need to help me with this, because I don't know. I don't even know what this means. But Kirby Super has asked, can you mix draw objects and draw sprites?
Okay, so draw objects is the function that, like draw sprites, draws all 3D objects that are currently loaded into memory.
Okay.
So draw sprites is the same. It just draws every single sprite to the frame buffer, to whatever draw target you've currently got set, which by default is the frame buffer. So you can mix them in the sense that you could have a program that says draw objects and then draw sprites. You could have a 3D game going on, or a 3D background with some 2D stuff happening over the top. But I say you can't. This is a can't in very heavy asterisks, because you can. It just takes a lot more fancy tricks. It's very difficult to draw 2D behind 3D. But you can draw 2D stuff over 3D stuff. For example, you have a 3D game and you draw a heads-up display over the top. Have a 3D game, you draw a mini-map over it, or something like that, or a health bar, or whatever. But to have like a 2D background with a 3D thing drawn over that takes a lot of clever masking, basically, with things called blend modes, where you need those draw targets that we mentioned earlier, and you've got to start cutting things out of images and sort of getting very, very clever with them. If you want to know more about that, Kirby, and you are in the Fuse Discord, then I would recommend that you speak to somebody called Gothon, who is the Fuse, I call him the Fuse Alchemist, or the Fuse Sorcerer, because the stuff that Gothon does is just completely outrageous. Gothon does stuff that I didn't know was possible at first, and I was like, you're not allowed to do that. It's like, well, you can if you just do this and this. It's like, he is a Fuse god. He absolutely is.
Wow.
Yeah, absolutely.
Very, very
yes,
nice.
I recommend that. And I see that has already kind of been answered as well by James Morris, which is great. And then the What Brand Ginger Beer.
Yeah, I did see James
already.
Very helpfully answering a couple of those questions as well in the chat. I think that might be all of the questions I saw. I'm sure people will have many, many more as we continue on, but I think it was nice to take a moment to answer some of the most burning questions.
I'm just reading that comment from SAVT from what shape is that?
I don't know whether this is a chat or our community specific thing, but recently, or for a little while now, rabbits or bunnies are banan.
I see, bananicular.
Somewhere between a rabbit and a car, I guess.
Is it like what? It's like a banan to a rabbit. What Mousey is to actual mice.
Maybe that's the best way of thinking about it. Yeah. It is an interpretation.
what I like is putting EULA at the end
Yep,
of
very good.
things.
Very, very
I
nice.
also I noticed that because I do that a lot. When I say that something is something EULA, I find that very funny. And so, Sav, you're a person after my heart there. I enjoyed that use of language that you've got there. Okay. Right. I'm eager to get back to this because I want to make sure that before we sort of get to the 8:30 mark,
Yep.
that we've got a couple of things in place. Now, shall we do a share here, and then I can pick up
yes.
the project from you, and then I can take over if you like?
Yeah.
Because you've been doing lots of hard work there. So yeah, you might as well give me a turn. So if you press minus to return to the main menu, and then, pardon me, programs. It's the problem with drinking loads of ginger beer. And then you want to press the R button so that you are over there. Yeah. And then on Mousey test, press the X button. And then you want to go share program. Okay. Now, I should be able to pick that up. Just give me a second.
Okie doke. Because last time we shared this, we're both friends on Switch, and we shared this in a way that is accessible to Switch friends who also have FUZE4. So hopefully fairly soon it should be accessible for you to download. It was pretty much instant last time, wasn't it?
Yes, indeed. I think I should have that. Yes, I do. Great.
Excellent.
Okay.
So
Brilliant.
when you're ready, I can switch over to your Switch.
I am indeed ready.
Okie doke. All right. So, chat, you're going to be seeing Dave's Switch now, and Dave has up the code that we just wrote together on my Switch, because I've just shared that project with him.
There we go. Hey.
Nice.
So. What we can do now, what I wanted to do here, because I wanted to do this bit because it's going to take some formatting stuff, and it'll be easier to just type it than to describe this particular thing.
Okay.
So what I want to do is to do the thing that I alluded to when I mentioned these, which is sort of, so we've seen one use of these enums, which is when we do our create item, if type equals item cheese, then we're going to do some stuff. Now, what that stuff is going to change depend on the type. So we're going to want to set an image for our item. But what image do we want here? Well, good question. Okay, we might want to also, not a sprite, sorry. We want to maybe set the sprite scale.
Right. Just like we did for our Mousey sprite.
Exactly, yeah. We're going to want to do it for item, but what scale do we want? Well, we don't know. We could have particular stuff in here, like we could do we could reference particular variables in here. We could have like cheese image at the top, cheese scale, cheese, etc., and put them all in here. Or we could go and, in fact, the way I'm thinking about this, we might not even need. Maybe I'm thinking a bit too far ahead, actually, because this. What I'll show you here is sort of the long way around, and then we'll show you the more convenient way. We might have to go back to something like this if we decide that we need lots and lots of different stuff.
Yeah,
but if we ended up with lots of different things, right? Yeah. Etc. Right, set sprite image, blah blah blah. Right, we might also end up with, if type is something else. This is going to become quite a large series of things, and there's a way to shrink this down into just one set of things. And we do that with this clever means of using those enum types. So rather than checking the type and saying, oh, if it's cheese, then do this. If it's this, then do this. If it's this, then do this. we can actually put all of that data, the image, the scale, whatever else it might need, into a big bunch of data that we can then go and get with these values, the cheese and boots enums. So I'll describe what I mean by that. I'm just thinking, where should we put this? And actually, the way I like to do this to enable us to just sort of move it around very easily is to make a function to do this. And I like to put this function usually at the very, very bottom of the program with a bookmark to easily access it. So this is just a, we'll call it init item data. Init item data. This is going to return something to us called data, and we'll make that here. Just going to preemptively make a bookmark.
Nice. And just while you're doing that, the bookmarks, we saw them last time, I think. It's a really, really nice way to jump around your code by just pulling up that bookmark section on the right-hand side and selecting the different bookmarks that you've named and created.
In fact, tell you what, let's make a couple more because it's going to be very useful to us.
Dave, while you're doing that, I have a very important question to ask from
Yes.
Arch. Arch asks, quick question, is the red guy giving a thumbs up on the thumbnail indicative of real life, Dave? In other words, are you a red sort of blob man?
I see the thumbnail. I'm so glad that you did the in other words as quick as you did. Because I thought, oh no, I'm going to be silent now because I've got no idea what he's talking about. It's surprisingly, it's harrowingly accurate. Okay, I'll just say that. It's especially the permanently sort of slightly angry, face he's got. Oh. Not angry. He's just got like he's got a look. He's got an edge to him.
It's determination. That's what it is.
It's determination, yeah. I remember when I saw that, I thought, I like that. I really like how you're presenting me there, actually. Yeah, and he hasn't got fingers, really, just a thumb. Is that right? He's got like a lump and a thumb. Yeah, it's a curse.
What else do you need to write code?
That's right. I mean, you've heard how fast I can use these thumbs here when I'm typing. So just making a bookmark for our enums so we can go quickly to that and then quickly to the item data that we've made quickly everywhere else.
Also,
okay, so
sorry, Dave. I did just want to say as well. Steve's Gaming says, "I'd just like to point out that Dave is awesome and us fusers love him to bits." Not a question, but a very important thing to read out, I think.
Oh, Steve, that's very sweet, and well, I love you all to bits as well. That is very, very kind, Steve. It means a lot to me, mate. And but you don't get to see me at home, really. So before you say I'm awesome, yeah. Okay. Right. This is quite a weird little array of stuff, and it's going to be an array of structures. Where now I'm going to lay it out vertically. Otherwise, we're going to have sort of all sorts of things on one line. So we could have like dot, scale, dot, etc. in here. But as that gets bigger, it just becomes hard to read. So what we'll have is a dot image. Right?
Okay.
And we could, maybe if we didn't want to have loads of load images here, it kind of doesn't matter though, it's fine. We could have these images stored separately and then like put them in via another means, but it's okay. We're going to have an image. We're going to have a dot scale. And this will be an X and Y vector. We'll do 1, 1. We'll multiply this by something. In fact, actually, we could, if we wanted to, just use scale as a multiplier. And then, yeah, that's what we'll do, actually. It's kind of easier to do that. So we'll just have scale as a number that we then multiply the 1, 1 vector by later on. You'll see what I mean.
Okay.
We'll also have, we might as well have a dot name. Right? Because then we might want to say, like, item name got at some point, or like something. You know, it could be anything. any purpose. I like to just, it's nice to have these little things that we could think ahead with.
Yeah.
If there's anything else we might want to have here that is specific to the cheese, I'm just thinking.
We've got our image, we've got our size, we've got our name.
I think we're okay for now because we can always come back to this and add as we need.
Yeah, if we find down the line that we are missing something there, it's easy enough to include it or to update it to include that.
Yes, exactly. And yes, I was just going to say to Red, you should totally feel free to repost the question.
Yeah, sorry if we missed it earlier, Red.
I know what we'll need in here. And it comes with this image part. Now, let's just put a thing here. I'm going to say this is our cheese, obviously. We could also put like 0 here because it's reminding us that this is the value for our cheese enumerator. It's
So right at the very top of the code, we've got our enums and cheese was 0, wasn't it?
That's right. Yeah, that's exactly right. And okay, so into our load image, what image are we going to use? Now, I do know of a rather fetching cheese asset.
Perfect.
And that is in Enums. And I believe it is in this Gothicvania Extras pack. And somewhere here in items, there's a delicious looking cheese.
Look at that. Perfect.
It's a really nice cheese. We could even get some bread with it. This has also got some nice other things, right? It's got some keys. It's got all sorts.
Potions, some apples.
Look at
that
actually, if we end up using more of these, then we should probably... we should probably change how we store the image. But for now, it doesn't matter.
Yep.
So we're going to paste this whole sheet, this whole image, into our code.
Okay.
Like so. And make sure that's there. However, this image has got lots more than just the cheese on it. It's got also...
Because right there, in that section that you'd put in quotes, that was this whole set.
The whole thing. Yeah. This whole image is just this one big tile sheet full of stuff. So we're going to want a tile property to say which tile number this is.
And the cheese is 14.
The cheese is 14. So we'll have a dot tile equals 14. So we can go and get that as well. Okay, so now we've got a piece of data here. If we wanted to have the boots, this would look something like this. Yeah, where we've got
relate to 1,
dot image equals whatever it is for the boots, dot tile for the boots, dot scale for the But we'll come to that as we need it, because otherwise it will complain that we've got empty stuff. So Red's question: is there any way to import your own custom music into FUZE, like uploading it to the FUZE website and being able to access it in your games? Unfortunately, not. And there are various ways that we have thought about going about it. One of the ways that we were really interested in, but we couldn't really move forward with because of just lack of communication on their side, was we wanted to link to other music building apps like Korg Gadget on the Switch, which is a brilliant application that I have a lot of fun with myself. And similarly, because it has to come from within the Switch, right? If this was a Windows application, then it's a very different question, which is why we are working very hard on making a Windows version with some improvements. But because of, obviously, as soon as you start to talk about, can I just go and download some data onto my Switch? Well, you might say it's music, but obviously there's no guarantee that it will be. As soon as you allow somebody to put things into the Switch that is data that the Switch doesn't really necessarily know about or want, that's where you get the vulnerabilities. So in order to protect the Switch, which Nintendo cares a lot about, we don't allow that. We don't allow for, it's not a very open system. Is that something that we'd like to change? Yes, absolutely, but it's not something that is likely to change in the Switch version. That is, unfortunately. So I'm sorry to say, Red, that you can't. However, you can write your own music in the code using the synthesizer commands. So you can use code to actually manipulate the speakers of the Switch to generate particular waves, give them note values, and it is quite complex, but some people have made some incredible stuff. So yeah, I do recommend checking those out. There's a couple of streams where, in fact, quite a lot of the streams actually in the FUZE stuff have some custom music going on, which is really impressive.
If I remember correctly, we saw some beautiful examples of that in the last Game Jam stream that you hosted as well. I'm struggling to remember specifically which projects it was, but I
think there was one that Vinicity made that was actually a music creator.
Oh yes, it was so good. Yeah.
It's so cute as well. It's like this little toy where it's a sequencer and a drum machine. And you could do all sorts with it. They're really
such
impressive.
A good design. Yeah, it was really nice. Yeah, and
I mean, I've also toyed with it a bit myself, but not creating something like a sequencer. Although that is something I should really have a look at that. But because the content that I generally make is more for the worksheets and that sort of thing, the level of complexity is quite high for something like that. But I have played a lot with the music commands. That guitar program that I've showed you, Dom.
Oh, it's so good. Yeah.
Uses some of that stuff. It's all just waves. You do need to know a few bits and bobs, but it's nothing that a few tutorials can't teach you. There is a FUZE tutorial that teaches you how to write code that makes music. So you can go and but you'll need to sort of know which notes you're putting in if you know.
Excellent. And people can find that on the FUZE Arena channel.
They can find that actually just in the help.
Oh,
there is a
fantastic
tutorial called Making Music, which shows you how to use the play note command to make various things happen. And it gives you an example of, what these numbers mean. Here's some different values, some different numbers to represent rests and different things like that. And then making a melody, playing that melody, etc. So good thing to have a look at if you're interested in the music side. Okay, so, right, we've initialized some item data. Now, we need to store this into a variable. So let's do that. We'll do it just when we do all this loading stuff. We'll go item data equals init item data. And now if we decide that this isn't where we want to do this, we can just put that somewhere else. But because it's in a function, it's just nice and neat in one place. Super, super helpful, especially as that gets really, really big. Nice to just have it at the bottom out of the way rather than up the top and cluttering everything up. Right, so we've got all our item data. We can now use these enums to go and get that data. So if the item is not a null sprite, what we'll do is we could do it this way. So I asked you, what image are we going to put in? Well, we want item data indexed by item. Sorry, this would be item cheese if it was a cheese, but we are actually passing this item function a type. So whichever type we give it, we can just put that type into here, and we'll use that image.
Right.
We'll set the scale to item data type of that scale.
Yeah.
Now, rather than typing out this item data type thing again and again, which could get quite annoying if we've got lots of different things in there, I like to do something like this and just make a little copy of that item data, just called data, and then it can just be data.image.
Perfect.
And data.scale. It's just a nice way to not have to type the same thing again and again. It's also a little bit faster.
Yeah.
Because if we have it this way, every time it reads this, it has to go and load all of that item data again. It goes, okay, what's the item data again? Let me go back and find what that is. But if we've got it stored as a little handy local variable here, then it only has to go in 2 lines up to find it, basically.
Wow.
It's just a little bit faster.
That's really, really interesting. I didn't realize there would be such an immediate kind of correlation between something like that, but it makes total sense.
When I say a little bit faster, I mean so imperceptibly small that
Yes.
it's actually not really worth talking about. But it's an interesting point, and I do like to think about that sometimes.
Oh, sorry,
that
Dave.
got a nice little super chat there.
Mr. Docina sent a £16.57 super chat. Very glad to see you doing custom game videos, VideoDojo. Quick question on the
I
music
lost you.
bit. Are
Okay,
there
I'm
any
just,
FUZes who are willing to
listening to the
create FUZE
message.
code for music you send them? As in
Oh,
turning
does it
your
play
song
an
into
audio?
FUZE code.
Yeah, there's a little text-to-speech. So, Mr. Docina, thank you very, very, very much for your super chat. That's very, very kind. It's so great to see you as well. It's always really nice when when you stop by chat. Mr. Docina was asking, are there any FUZes who are willing to create FUZE code for music you send them? I guess kind of translating a song that is created outside of FUZE into something that could be used in a FUZE project. Those who are most familiar with the synthesizer stuff that you were talking about earlier. I guess I'll ask that question or put that question to Dave, but Mr. Docina, thank you again. That's really, really kind of you to send over. And as I mentioned, always very nice to see you in chat. And of course, I'm always going to be making custom game videos, be it in FUZE or GBG, because it's really important, I think, to show that even somebody like me who has really not ever done anything like this before absolutely can, and with the help of incredibly talented people like Dave and the other members of the community, we are building resources that anyone can use and use as a bit of a springboard to get started in these really accessible and really powerful tools. So yeah, much appreciated. I guess, yeah, Dave, I feel like the answer would probably be talking to folks in the FUZE Discord, but maybe if you've got any other thoughts about that. I don't know how
100%.
familiar Mr. Docina is with FUZE at this stage, so I don't know whether they've already got a project ready or...
Right. I would say two things. First, I'm sorry for talking a bit over your super chat. I can't hear the audio for that, so I didn't realize
not at
I was
all.
talking over you.
Don't worry, Dave.
Secondly, I would join the FUZE community and ask, because the chances are that yes, but it also obviously depends on the complexity of music that you send them. If you're talking about, a little bit of sort of video gaming music with like maybe 3-4 voices doing some, like 3 or 4 instruments doing some melodies, then yeah, great. If you're talking about, I've got a piece of dubstep that I want to transform into FUZE code music, then that might be more difficult, because obviously, of course, if it's very, very sophisticated, or if it's samples, then that's difficult to trigger. In fact, it's impossible, because obviously, if you're triggering some vocal samples or something like that in your piece of music, well, if we don't have access to them, then we can't do that. What we can do, though, is create synthesizer melodies and stuff. So it depends on the complexity of the music, but I'm sure that you'll be able to find somebody who's willing to at least help out with that, if not give it a try. And if you can't find anybody, and it's a piece of simple-ish music that you reckon it could be turned into some FUZE code music, then I'll absolutely try and help with that as well. So you can always get in touch with us at FUZE. You can email us at contact@fuze.co.uk. Anyone is very, very welcome to do so, and we'll always try and help. So hope that answers your question.
And I also believe there is a link to the Discord in the description of this stream as well, as in the FUZE Discord. So, Mr. Docina, if you're not already, definitely do head over there to check with the very talented and very generous folks over there as well.
You're very kind. Awesome. So, right, I really want to... Oh, you've had it on the Switch for... I've just read the answer there. It hasn't started in FUZE yet, but had it in the Switch for years now. That's so cool. Obviously, even cooler if you were trying it. But obviously, I understand the giant backlog, okay, more than most people. I really understand that a lot. So no hard feelings at all. And thank you so much for getting FUZE and supporting us. It means a great deal. It really, really does. So thank you. And obviously, when you do decide to start on Fuse, head over to the community, and we'll all give you as much help as you need. So, in the interest of getting some cheese visible, I've realized that we also need to set the tile for our image, because we had a tile. Now, there is an extra parameter in set sprite image which allows you to just put a tile in here. The only images that we have right now use tiles, but if they didn't, then we can also handle that. But we'll come to that when we need it. Okay, I don't want to cross too many bridges before we get to them, and we already have crossed quite a lot of bridges before we've even conceived of the bridge, using the power of these sort of very generic sprite functions. But this now will allow us to create an item. Now, we also might want to tell it a couple more things. For instance, where we want that item to be on the screen. It's probably quite a helpful thing. So we'll do that as well. We'll just give this an X and a Y position. We'll create item. We're going to go, right, create item, a cheese at this particular place. And we will say item.x equals X, item.y equals Y. And now we're just putting, pardon me, that item into that location. And we are returning the item as well, so we can do all sorts of stuff with it. And this should kind of be all we need. I'm just realizing. Hold on a second. Let me just have a little think, because once we have got the item, we then want to. I don't even think we actually need to return this. We might just return void, and then we're actually putting it into that place. Because it will already be an item in that slot. So I think we can just return void here. We'll just give it a test. Yeah. So we've got our create item. We're probably going to find that something is wrong. But let's just give this a try. Oh, God.
It's all part of the process.
Here we go. Let's put one at 1010. And what have we got? There's a problem.
Okay.
Oh yeah, we wanted a vector instead of, sorry, I shouldn't skip over it. So this was saying, you given me an incorrect type for the second parameter of set sprite scale. I expected a vector, and we gave it an integer.
Yep.
Which, because we said that the scale would be a multiplier, and it's expecting a vector of x and y, so we need to do 1 multiplied by the scale multiplier that we put in. So if we remember, in the data down here, the scale bit of data that we put in was just an integer, 2, just a number. And it's expecting this 2 in brackets, in square brackets, so we need to give it a vector, multiply it by the scale multiplier, and there's our cheese.
Oh, that's one big cheese.
It's massive. It's absolutely humongous. Let's not make it so big, eh?
He's going to be delighted. Also, that was a great example of how the errors are displayed and how kind of natural the language around what is causing the error and what it's looking for is. Well, really helpful for when you're trying to work out what it is that's actually wrong with the code that you've created.
So we've now got a beautiful system
that
can create cheese with just a single little function, and it's all nice and in an array of cheese items. We could now say for I equals 0 to however many items we have, if we wanted to make a cheese in every single one, we could say create item underscore cheese at a random x position out of, I don't know what's going to be worthwhile here, but let's say like 100, but we want to minus 50. So we're saying a random x position of minus 50 to plus 50, and a random y position of minus 50 to plus 50, and it's going to fill this area with cheeses. Yeah.
There we go. So we've done all of the kind of foundational work to handle the creation of those sprites, and then now we're just kind of reaping the rewards of that by very simply, we just saw how quick you were able to type that out. Say, where are we going to spawn the cheese? How many cheese are we going to create? Yeah, it really that's a great demonstration of how useful it is to properly set that stuff up. Because, you know, it might be that you create 10 levels, and if you haven't been so forward thinking in how you set that up, you're going to have to go in and say, okay, I want to place one cheese here, and you're maybe even like defining that every single time and positioning that. Yeah,
100%. 100%. Oh, James, good question. Is there a way to detect the walls and not draw a cheese there? Yes, there is. We will need a different type of doing this. A different way of doing this. I'm just sort of just wanted to spam out a bunch of cheese just to see if this worked properly. But we'll need to have it would be something like this. Maybe we have like a valid variable which begins life as true, and then we first of all we want this in some sort of for loop. So let's say we had for I equals 0. I've started this now, and I really hope that this works. So for I equals 0 to 100 loop. So we want 100 of these things, so that's definitely going to happen. But for each one, we want to know if that actually is a valid place. So let's make a variable, and we'll say, we'll say, maybe if we do, I might write this and then change it. No, we're going to want to start this as false, of course. And then say not valid. Oops. And then we'll immediately say that valid is true. So this is a bit of a logical sort of thing that you learn to pick up. It's a bit of a technique to do this exact sort of thing. So we want 100 things. We're going to assume that it's not a valid placement first.
Okay.
And then we start this while loop that is going to repeat as long as it's not a valid placement.
So that
the first thing that we do...
Sorry, Dave. No, keep going.
Sorry.
Yeah, no, I think you're about to answer it. I was just going to say, so we're starting by assuming it's false, it's not valid. And then this is going to establish whether or not it is valid. So I was just going to say, so what is it that we're going to be determining in here?
So we're saying valid equals true first to say, okay, let's assume that this one that we're going to place is valid. Then we check if it's not valid, and if it's not, we make valid false. And then at the end of the loop, if valid remains as false, then it will happen again. But if valid remains as true, then we've found a valid cheese, and we'll move on to the next one.
Got it.
So we need to now do a lot of messing around. we need to make a cheese. For sure, we definitely need to do that. Let's make a cheese. Let's do our random position. I should have kept this line really, but hey. Minus 50, right? So we're going to make a cheese, and then we're going to check if that cheese. In fact, maybe we could just make the cheese first. Actually, yeah, we'll make the cheese first in that place. There's better ways of doing this, but okay, it's going to be inefficient. That's fine. Just move on. This will be in a function where we're doing a few different things better. We're going to have to type this out. Type the same thing twice, which just immediately makes my skin crawl. But hey, that's fine. Because I don't want to keep overwriting a cheese with another cheese, another cheese, another cheese. I want to just change its position until it's in the right place. So we're going to make a cheese, assume that that's not in the valid place, and then while it's not in the valid place, we're going to check. So we're going to say collision equals collide map, and we are colliding with items I, which is the cheese that we've made. This definitely should be done differently, but it's fine. It's fine. And I believe, yes, Sprite and resolve. Yeah, that's fine. So it's just Sprite. So we're going to say, does this... In fact, it doesn't even have to be collide map. We'll do detect map collision. Is that even a function we have? Let me remind us of that. Maps, detect map collision. Yes. So then we don't need any of this other stuff. So just detect map collision. Okay. And then we'll say if there is a collision, then in fact, well, really, we could just put this. We'll just put that. We don't need that variable there. Let's just take this and put that into our if statement. We don't really need another variable here. That's fine. So if we have collided with the map in any of the places that the map can collide with, so our collision boxes, like any of our walls, then what we will do is we will choose a new location for that cheese. Y equals R&D 100 minus 50. No. What am I saying? I told you that this would be. One thing we want to definitely do is say that it's not valid. And if it's not valid, we also want to do that.
I just want to take a moment as you're typing this out to say it's really, really fascinating to watch you figure something out like this on the fly, because obviously with everything that we do together, you do a really wonderful job in making sure you know exactly the approach we're going to take. And of course, there's lots of different approaches that you can take for any particular task that you're trying to achieve within your code. But to see you go through this and kind of do it on the fly and the way that you figure it out, and I think it's really important that folks in chat.
Oh, that's kind.
No, I think for them to see this is, you're really, really skilled in what you do, but you've also got to think through using that toolkit that you referred to earlier about of like you need to know how these things work together, figuring out what the combination of those things is, what the order of those things are. I'm sure it's like I would be terrified having to figure this out on the fly, but it's so good to see how.
Thank you, Dom.
It.
It's very, very sweet. I appreciate that a lot. It is something I have practiced a lot. Don't forget.
Yeah.
Whenever I do the workshops with the kids and they're asking me to do various things, this is the sort of thing that I will do. But I sometimes try and go kind of quickly because it's all in the interest of time. But I'll explain my thinking, okay? Because it's all about just breaking down this sequence of instructions to just be the logical things you want to happen. So we want 100 cheeses. First, we make a cheese in a random place. Then we assume that cheese is not in a valid location. We say, okay, as long as that cheese is not in a valid location, let's keep repeating this thing.
Yep.
Okay, so let's say that it is valid first, because if it is valid and it doesn't detect a collision, then when it gets to this repeat here, valid will be true and we do not need to do another one.
Yep.
It will just move on to the next cheese. However, if it does detect a map collision, then we need to say, okay, that's not a valid cheese, even though in my opinion, all cheese is valid. It's not a valid cheese, and we have to move on to doing this again. So valid remains false now. Valid is changed to false. When it hits that repeat, it will happen again.
Yep.
But also what happens when we detect a collision is we just make a new position for it. And now it should never collide with a wall.
That's looking good so far.
In fact, let's really test it and make 1,000 of them. Oops. Oh, of course we can't make 1,000 of them because... Why? Why, Dom?
Because we already defined that it's 100.
Yes! Let's just say len items then.
Okay.
And let's say however many sprites we make, we'll fill it with cheeses. There we go.
We made a cheese block out of cheese blocks.
He's covered in the cheese.
Oh, it's so nice seeing how it's worked around the wall where it would be colliding, and you can see. Oh yes, good idea. So this is going to expand the radius or the area that the.
Yeah, exactly. And really, these should be put into some variables so that we can just change it once. But come on, we're not gonna keep this. So. Right, there we go.
Hey, perfect. There you go, James Morris. A little speed run from Dave of how to spawn the cheese only where there is not a wall.
So, I mean, that is one way of filling up the level with sprites, I suppose. Mousey wins the cheese lottery. Not clickbait. It is every mouse's dream. This eat yourself into your own cheesy demise.
What a way to go.
I can think of worse. I really can. Make it Stilton, and I'm having a hard time not doing that.
Yeah.
Okay. Love me some Stilton. Okay. Right. That gets
fire away,
across.
RJ. Sorry.
Yeah. Go for it, RJ. How would you do the second floor, like in the vanilla game, like with the mouse springs and such? Or you had to ask the most difficult of all of the features. So I wanted to use FUZE's 2D engine to show making a game in FUZE, because that is, I believe, where you should start. Because then, you add another dimension and you're in 3D and you can start to do other things. Also, the sprite system is in 2D and it adds a lot of infrastructure that lets you, like the detect map collision, detect sprite collision, that sort of thing. So I wanted to showcase FUZE's strengths, which is in its 2D sprite system. The 3D engine is incredibly powerful as well, but it doesn't have as much infrastructure as the sprite system. So if we were in 3D, then the extra floor would be trivial because we're just jumping up a floor in 3D. And not trivial, but you know what I mean. It's the dimension is already there. In 2D, it's a bit more difficult. We would have to either have another map that we can jump up to, or perhaps we just represent it with Mousey being a bigger size, and certain areas of the map are restricted behind Mousey being in this elevated sort of size. There's many ways to approach it, but I don't know if there's many ways to make it look really great as it would in GBG, which is sort of really fundamentally a 3D game creation tool.
Yeah. We're kind of, anytime you try to make something that appears 3D in GBG, you are doing a lot of fakery there, because every game, whether or not you can only move left and right, for example, is still a 3D game.
Yeah, exactly, yeah. And you can still do that in FUZE. You can have a 3D world and just treat it like a 2D game. I mean, absolutely you can, but I wanted to show off the sprite system and the 2D game creation tools, like the image editor and map editor. Sadly, we don't have a 3D model editor or a 3D map editor, which is something we desperately want to do. It's just, it wasn't a feature that we really had the development scope to add or the time to do it. It wasn't tenable, it wasn't viable to add it when we were making FUZE. And since then, we've always had different priorities and other things going on. So it's not something that we've added yet, but it is something we definitely want to look at, especially for the next versions of FUZE.
But it's also worth saying that you do have 3D models in the resources in FUZE. There are existing ones, and it's a really nice catalogue of 3D models as well. You
can certainly load in your own 3D models, and to be honest, you can do some pretty impressive stuff by using the object group function. So even though you can't make your own 3D models, you can kind of do that by bunching objects together and then grouping them.
Right.
And by grouping them, what you're doing is you're giving them all a common origin, so that when you rotate them or move them, they all move or rotate together around an origin. And so you can do things like, position your, if you were making a first person game where you've got like a lantern or something like that, you could have like a hand with a lantern with a light in there, group all those objects together, and now they are moving around with that sort of group of objects. So you can actually do a lot of stuff with the object groups. And James Morris also brings up the terrain function, who has pushed that function further than anyone else. James has done some incredible things with the terrain function. And yeah. So yes, thank you very much for stopping by as well, Mr. Dusina. Good to thanks for the questions.
Nice. So we have. Oh, sorry, Dave. I was just gonna say we have our room full of cheese. The cheese knows not to spawn inside the walls. We're not gonna have a Castlevania situation here where we break a block and we've got chicken inside, because all of our cheese is nicely accessible from start point inside the test room here.
Yeah, so this test room, it's serving its purpose. We've we've got some good stuff. We know exactly that we could use this exact thing later. If we wanted something like this, we would probably make a function to do this. Maybe a function called like spawn cheeses.
Yep.
And it would go through making a number of cheeses, and we could do something very similar. Or what I was thinking, actually, just to quickly showcase, is we could use something like, now I won't write the code for this because it's going to be more involved, but we could go into the map of Mousey, and let's say we wanted specific cheese spawn points, but we didn't want to have to manage those positions ourselves with numbers and remember everything. We could go into our collision, we could mark areas and call it cheese as a location.
Yep.
And then we go through the data, get all of these location flags called cheese, extract their X and Y positions, and then feed that into our create item function, making it a cheese.
So instead of having to kind of figure out the X and Y position and type that in manually, you're setting these flags in the map editor so it's nice and visual, and then you're just referencing those in your code instead.
Exactly right. Yeah,
that seems like a really, really lovely way to do it. That's a bit more immediate, and I think that's the thing that's always so great in the FUZE stuff. Not only just testing stuff out and then getting to play it is very immediate, but that kind of direct link between these visual things here, like the map editor and the sprite editor, and the code. It's so easy and so quick.
Totally. I mean, it depends on what you want to do. Like, if you want a game that's like spawning cheese and it's falling from the top, like a falling rock sort of type setup, or you want to have 1,000 cheeses around the place, then you would never place that many flags yourself manually. But you could just go and if you wanted a certain number of things like coins in a level or anything else like that, then this is a really nice way to do that without having to manage those X and Y positions yourself and remembering all their locations and going and trial and erroring it. And it's a really nice way to go and embed this information into the it is the way to embed that information into the level. Steve, they don't have to be called cheese 0, cheese 1. You could have duplicate names for these tags, and then you would just loop over all the locations and just check if that location's name equals cheese, then create item location.x.y item cheese.
Also, I won't read out RJ's full comment, but it's great seeing RJ thinking about how they'd perhaps handle the multi-level, kind of the multi-height layout.
Oh, yes, indeed. I like that idea a lot, actually. I do indeed like that idea. I think that the idea behind that, with some sort of parallax, so that the bottom floor becomes like a background now that scrolls in a different way. Maybe that is a very cool sounding idea. And yeah, I'd love to see that sort of thing actually. But yeah, so just to sort of put a nice underline, and to say where we're going to go next, because what we didn't get to today, which I was hoping to, but the sprite stuff is more. I wanted to explain it properly. With our nice sprite functions. What I want to get into is getting the cheese to behave in certain ways. So I did show this last time as well, but I had a similar sort of test idea with like a hoovering mechanic where when we press A, we are sucking in the nearby cheese, like so.
Yeah, really great.
And there's a couple of different ways we could do this. And we could use this interpolation function to do exactly this, which is probably the way I'm going to get you to do it. And we'll talk about that really, really helpful function as well. So I'm thinking we'll do that next time. We'll start looking at applying different behavior for our different types of sprites, whether that's a cheese or a boot or etc. etc. And I think that'll be a really nice sort of jumping off point then to start maybe designing a level, and then populating it with some things, or maybe we could think about different mechanics that we want to try in our test room, because it would be really cool if like we have a bunch of mechanics that we know that just work, because we've tried it in our test room, and then we make a level and it's literally just a case of like, oh, let's put this here, let's put this here, let's put this here, and we press play and it just works.
I think
that'd be awesome.
I think that would be so fun. It's that kind of delayed gratification thing, isn't it? You get all of your essentials down, and they're all set and in place, and then it's just a case of having some fun and building the level using those mechanics that you've established. Man,
we will of course have to go back a little bit and start tweaking stuff, and that's you're going to have that no matter what. It just is a guarantee basically. But the more work you do it in the beginning, the easier it'll be in the end. So
I suppose there's always going to be a push and pull, and that's a natural part of fine tuning the game, isn't it? And
exactly. I will also, dude. I will just go and I'll share this program. And then we can get that onto yours as well next time. We can worry about that next time.
Excellent.
Just to remind myself that that's done.
Dave, I think that's going to do us for today. That's a really nice point to round us off, I think. We had a bit of a break between this and the last one, so it was great to start with a recap. But then to really lay those foundations, I think you said we were kind of making those tools around sprites and creating create and what was we had create and
update, which we haven't got to yet.
Yeah, so we've got our create portion there.
Yes,
and we also saw that in action with placing the cheese sprites in here. But
exactly. Update will come next.
Okie doke. But we've got our room there to grow. So we talked about a kind of speculative second item. So we've got cheese, and that same basic format for the cheese could be applied to something, because we're collapsing the differences between those different items.
Lovely. Excellent, Dom. Such a good learner. Such a good student.
Well, it's been all down to your wonderful tutorage. Chat, I hope that this has been a helpful little bit of insight into the powerful tools that are inside FUZE4 for Nintendo Switch. FUZE4 Nintendo Switch, excuse me. There is links to pretty much everything Fuse related in the description of this stream, and I do recommend you go back and check out our previous streams as well, but also the plethora of really useful resources on the FUZE Arena channel. I'm going to spam it in chat just so folks have got access to that here as well. Definitely go check out and subscribe to FUZE Arena too.
Thank you so much, Tom.
No, it's such a good resource. So my pleasure, and really always so lovely to have you, Dave, and your expertise. And anytime, please do stop by.
Oh, well, I really look forward to the next one, Dom. Thanks so much for having me. Thank you very much for everyone in the chat for your lovely support and your comments and your questions. I hope I get to see you all again next time, and we can keep learning together and just carry on this journey. It's cool. It's a real pleasure, Dom. It really is. I can't wait to see what we end up with, Mousey, cheese maze wise.
Excellent.
It's gonna be good.
Yeah, definitely. All right, chat, thanks for hanging out, and I will see you on the Discord if you've got any questions there. We do have a little topic for Fuse stuff, but of course the depth of knowledge is inside the Fuse Discord itself. So I definitely recommend, if you've picked up Fuse recently, you head over there and share what you're doing and talk about the amazing things you're building with other fuses. Is that the good? Is that the correct?
Yeah, very much so. Very much so. Yeah.
Yeah. So
I'll also say, if you are in the FUZE4 section of the VideoDojo Discord, I don't always know that, because there's a few Discords that I'm in that there are, I'll get the little notification little circle up here, but I don't mind being pinged. So if you want a question answered, feel free to @ me, and then I will definitely actually see it and respond. I don't like the idea of sort of missing out. Obviously within reason, but don't ever shy away from doing that. And the same goes for you, Dom. If someone asks a question and you notice and I haven't replied, you can always feel free to ping me. That's fine.
Good stuff. Yeah, I'll be sure to do that.
Cool.
Nice. Okay. Well, I think it's time for us to wrap up. So, folks, until next time, happy building and bye-bye.
Bye-bye.